Okay. Good morning, everyone, and welcome to Casa Cuba at Florida International University. My name is Regina Rodriguez. I'm the chair of the Cuban Infrastructure Scholarship Competition, and I'm the president-elect of the Association of Cuban-American Engineers here out of Miami. In my professional role, I currently serve as the Chief Operating Officer for Carbonext, an environmental engineering research and development firm out of Gainesville, Florida. I'm also a University of Florida graduate. I have the pleasure of welcoming you to the 2019 Cuba Infrastructure Competition. This is a very exciting 10th year in the running, so thank you for being here this morning, and thank you for those of you watching on the web. It is a landmark year for me specifically as a new competition committee chair, and proudly take inventory of major accomplishments for the event, first designed to be a local and a state competition. Building on a solid foundation, we have attracted 4 top higher education institutes from across the United States, in addition to 2 Florida universities that will be presenting here and have presented in the past. The hosting committee for this event is made up of members from 2 sponsoring organizations, the Association of Cuban-American Engineers and the Cuban-American Association of Civil Engineers. I would like to remind everyone that this event is being live broadcasted thanks to Wen and his team online, and is accessible using the YouTube link in your program. Buenos días a todos y bienvenidos a Casa Cuba, en la Universidad Internacional de la Florida. Mi nombre es Regina Rodríguez y soy la directora del Comité de la Competencia de Becas y presidenta electa de la Asociación de Ingenieros Cubanos-Americanos. Actualmente tengo la posición de Chief Operating Officer en Carbonext, una empresa de ingeniería medioambiental y alumna de la Universidad de la Florida. Es un placer hoy darle la bienvenida a la competencia de 2019 para las becas sobre la infraestructura cubana. El comité anfitrión está compuesto de miembros de las 2 organizaciones patrocinadoras, la Asociación de Ingenieros Cubanos-Americanos y la Asociación de Cubanos-Americanos de Ingenieros Civiles. Y muchas gracias por estar aquí con nosotros hoy. Este año es un año histórico para la competencia, pues hemos logrado atraer muchas universidades fuera de la Florida nacionalmente y encontrar el compromiso final de 4 reconocidas instituciones afuera de la Florida, de los Estados Unidos completo. Queremos recordarle que esta competencia está siendo transmitida en vivo y puede accesar el link en su invitación. El resto de la competencia hoy será de la competencia, y las presentaciones continuarán en inglés. So the Cuban Infrastructure Scholarship Competition is an annual college-wide competition that aims to promote the interest in the future's reconstruction of Cuba's crumbling economy and infrastructure amongst the university-level teams. Joining Gainesville's University of Florida team and Miami's International University are multiple-time competitors in this competition. Since its inception in 2010, are the following first-time participants, and we're very excited to have you here, all the way from Utah, the Brigham Young University, George Mason out of Virginia, Georgia Tech out of Atlanta, Georgia, and the Illinois Institute of Technology out of Illinois. And we even have some from Spain doing some of their work out of Illinois. So thank you for making it all the way down here to Miami today. The 6 teams of finalists are vying for $12,000 in prizes that will be presenting their projects on how to improve Cuba's failing infrastructure currently before our 4 seasoned judges. All of the teams have submitted over the past couple of months real-life project proposals representing hundreds of hours of work. And today they will make their final oral presentation. Ultimately, they and the previous year's team may form part of the reconstruction process of Cuba that we're all aiming for. A nation which has far gone to provide adequate housing, transportation, safe water sources, and a waste management practices with efficient energy systems. So that's really where we want Cuba to be. For those of here in the audience, for our parents, for our grandparents back home, that's really where we want to see Cuba go to. At this time, I would like to recognize the presidents of each organizations and thank them for their support in this program, obviously the members as well. Roger Puerto from the Association of Cuban-Americans Engineers is not able to be here with us today, but he's definitely a champion of all of our great work. And Yvette Aleman leading the Cuban-American Association of Civil Engineers. She too is leading a lot of great work that us as members are very proud of. With respect to our sponsors, we're very, very grateful to Buya Gastrogar, owned by Carlos Intirium, who has graciously sponsored the Cuban Infrastructure Competition event for several years now with a $20,000 per year sustainable commitment. Many of you may be familiar with the original Buya Gastrobar restaurant out of Coral Gables and now out of Doral and Winter Park. We're also very thankful to Casa Cuba here today at FIU and Maria Carla. Casa Cuba is a new initiative by the Florida International University to build a leading intellectual and cultural center that will foster global understanding of Cuban affairs, culture through education, research and discussion of the arts. So thank you for hosting us here in this wonderful location this morning. Prior to beginning our program, I would like to thank those members of our CISC committee that have worked year-round to plan and host this event. It does take a lot of work, and it does take a lot of reading and looking at the competitors and mentoring a lot of the teams. So the members of our committee are listed in the back of your program, and the commitment from those individuals that are here today and were not able to make it is really outstanding. So a little bit more about the scholarship competition and what it really means and why I personally believe so much in it. And the importance of the competition is about our future, building from our past and those from our family members. And like I mentioned, this is the 10th consecutive year that we've been hosting and been able to organize the CISC. And we're really excited to see the students and professionals that have developed from this process as well, myself included. The goal here is to promote educational advancements and community awareness here that many deficits of the decaying Cuban infrastructure. We hope that more engineering students will become more interested in applying their skills, not just into U.S. problems, but also taking some of these, applying these skills back home into their countries as well. We hope that these students too become part of our young professionals and future of our industry, and will continue to be involved in organizations as part of the future reconstruction of Cuba. The mission of the Cuban Infrastructure Scholarship Competition and its committee is to promote high-level engineering and science that may apply to future improvements of the island and increase public awareness of Cuba's infrastructure needs. And that's really important too, because if we don't know about them, how can we do something as well? So this time I would like to take a moment to recognize our distinguished panel of judges who have dedicated a lot of hours in reading some of these proposals and are here today to provide their guidance and question of how to make these projects better. So the panel of judges combines decades of experience in different infrastructure sectors that the students will be presenting on. So I would like to start with Ingeniero Mario Golab. So thank you so much for being here today. Mario is a registered patent attorney and managing attorney at Golab Intellectual Property. So he brings a lot of interesting thought process in terms of both the engineering side and what it could look like from a a product, a project, and looking at all of those aspects. Mr. Antonio Delgado, the Dean of Engineering, Technology, and Design at Miami-Dade College. So thank you so much for coming here. Mr. Eduardo Vega, President of APCT. Mr. Vega is a long-term judge for our process and has seen the committee and the groups work and develop over the past couple of years. So he'll have a lot of understanding of what has been done in the past. So that's very exciting. And Mr. Mario Villar, electrical engineer and also Juris Doctor. So we have two types of lawyers in our group with engineering backgrounds, so we definitely do appreciate them today. Outside of the judges and the participants here that have traveled all the way down here to Miami today, we could not accomplish this event and the projects without great mentors. Myself, I have very great mentors here in the audience and back home, but the students themselves and how to compose themselves and how to present these projects. So keeping up with the event's traditional structure, industry mentors from across Miami and Florida were secured for each of the teams, and we are very fortunate to have some of them here today and some of them really helping some of the teams. So Ms. Maggie Giraldo from Kimley Horn, Mr. Jose Cueto from Miami-Dade Water and Sewer, Mr. Eric Bolness from ExxonMobil, Mr. Eric Silva from A&P Consulting Transportation, Mr. Pete Martinez from Game Changer Tech, and Dr. Elena Solo Gabriel, professor at the University of Miami. So the mentorship that these individuals provide can be lifelong, so please take advantage of that, and that's definitely what we're building this community surrounded here in this process. So, excuse me. This year we've received a multiple of ABET accredited universities proposals across the U.S. The judges have reviewed the written proposals here to date within the past months, and the proposals will be making 40% of the team's final score today. So from a judging criteria, this today completes the second part of the competition, which is where the teams will be presenting their projects. The oral presentations that will be given today will constitute of 60% of the final score. Each team will have 15 minutes to present their proposal today, followed up with 10 minutes of questions and answers from the judges, and also from the audience here, or those that are viewing live can submit some of their questions on our YouTube link as well. The judges will score the presentations today based on the following criteria: organization and delivery of the presentation, specifically looking at verbal proficiency and nonverbal image of the presenters; coverage within the time limit, being concise and efficient; proficiency in answering the questions; quality and creativity of the presentation materials. The judges will score today's, the scores from the judges today will be added to the written scores that we have already, and the teams with the highest score will be awarded first place and a $6,000 scholarship. Second place will be a $4,000 scholarship, and third place will be a $2,000 scholarship. At this time, we would like to begin our presentations. I know all of the teams are very excited. With your program, we have them aligned with the order in which they will come up. So we will start with the Brigham Young University team, and I'll let them come up and start their presentation. So please give it up for them.
Hello, everyone. As Regina said, we are the team from Brigham Young University in Provo, Utah. and our presentation is entitled Predicting Streamflow in Cuba for Water Resource Management. My name is Chris Edwards. I am a senior at BYU currently, and I will begin a master's degree in the fall.
I am Riley Hales. I'm also finishing an undergraduate degree in civil engineering. I'll be starting a master's program next year.
And I'm Jacob Lewis, also finishing my undergrad in April, and I'll be starting employment upon graduation. We'd also like to thank our advisors, Dr. Roland Hotchkiss from BYU, as well as Eric Sabilla, who helped us to refine this project. So as we begin, when we look at stream flow and water management, the reason that this is so important is because water is such a basic requirement for life here on Earth. It's something that we all need, and as such, it's extremely important for us to monitor not only the quantity but also the quality of the water that we have that is available to us. And just to kind of show the importance of this, to help create a better world, the United Nations developed 17 Sustainable Development Goals. These have been adopted around the world by 193 different nations. And of these 17, at least 11 directly or indirectly involve water quality management. And so it just goes to show how important water quality management and resources is as we look at helping to develop a better world. In Cuba specifically, with a population of nearly 11.5 million people, they typically use annually about 3.88 billion cubic meters of water. Because it's an island, Cuba has limited water coming in, mostly from storm flows, and as such, it just becomes even more important for them to be able to monitor this and know where this water is going for uses such as irrigation, drinking water, and industrial needs on the island itself. Of course, Cuba also sees the extremes of water as well. Cuba suffers from a hurricane or a tropical storm approximately every 2 years. These can cause major flooding and damage. Pictured here is Cuba during Tropical Storm Alberto, which hit last year in May. Caused major flooding. Around 3,000 people had to be evacuated and numerous lives were lost. Cuba also sees the other spectrum with droughts and water shortages. And this is where water resource management can really help to plan and prepare. Cuba has been lauded for its emergency response, and our goal is to help improve these processes. So to really effectively manage our water resources, we need three things. First of all, we need to know where the water is, things like stream beds, reservoirs, and things like this. Secondly, we need to know when the water will be arriving, and we also need to know the quantities, just to be able to manage and mitigate flooding and things like that. So once we have these, our principal goal is to help decision makers, first of all, to identify, and not only in extreme situations, but just in day-to-day use, where water is being lost and how it can be saved. And so once this has been identified, decision makers can plan more effectively and efficiently, which then allows them to respond quicker and more efficiently overall.
So the question then becomes, how do we get this information on streamflow? First off, you need people to take measurements. Currently, in Cuba, they have a system of precipitation gauges that are managed by volunteers. And additionally, stream levels and stream flow rates are measured by hand. In addition, in addition to this precipitation and stream flow data, to be able to predict stream flow throughout the country, we need to have an understanding of the topography and the terrain. This data then needs to be compiled, processed, and analyzed by engineers and scientists before it can be delivered to decision makers to be able to plan and prepare for events such as flooding. The Streamflow prediction tool is a global model that covers these steps. It combines precipitation data, soil use, and terrain data to give a 15-day streamflow forecast, thus enabling decision makers to have the data they need. It automates the steps of data collection and processing so that decision makers can focus their resources on the actual decisions. The Streamflow prediction tool is a global model, and global models have several benefits. First off, they take advantage of readily available satellite data, which is becoming even more higher quality and more accessible. This data is very accessible on the internet. While not substituting the need for local measurements and local data collection, it can be a viable addition, which can lower data collection costs locally. And these global models can be very useful, especially in areas where there is no measured data, there's no record, or it would be very expensive to implement a system. The Streamflow prediction tool was developed at BYU with the goal of giving decision makers around the world the necessary streamflow data that they need. It is based on a model produced by the European Center for Medium Range Weather Forecasting, or ECMWF, whose meteorology is widely accepted and used throughout the world. Every day, the ECMWF produces a global runoff grid, which is the amount of surface water level runoff that will occur throughout the world. The Streamflow prediction tool then routes this global runoff grid into the nearest stream, producing a 15-day volumetric streamflow forecast. For every river in the model, the Streamflow prediction tool produces a hydrograph. And a hydrograph, as shown here, shows the flow rate on the y-axis over time on the x-axis. To help with uncertainty that arises in any model, the Streamflow prediction tool produces a 52 forecasts each day, and this group of forecasts is known as an ensemble. And again, the forecast goes out for 15 days. Since there are 52 different forecasts, to help the users get a better understanding of the forecast, the hydrograph shows the mean forecast, the standard deviation of the 52 different forecasts, as well as the minimum maximum flows. There's also a single higher resolution model that is run each day, and this helps in areas with higher terrain variability. We'd now like to show you a brief video demonstration of how this tool works, which can be accessed online for free. Once inside the tool, you select the watershed you want to view. In this case, we'll select Cuba. This brings you to the map, and as you zoom in, you can see the stream network. We'll go into Havana. Clicking on an individual stream brings up the streamflow forecast. In this case, the different colors represent different levels of flow. The user can also select a forecast from any day within the last week. And again, this graph is the one I just explained. It shows the average of the 52 forecasts for that day, going out 52 days, along with the maximum and the minimum and the standard deviation. This data, the forecast data, can be downloaded by the user as a CSV file for their own use for each individual stream. The tool has some additional features, and one that we'll show you in this video is a graph of the daily average flows for every day in the year. And this allows the user to see whether today's forecast is above normal, if it's low. So the Streamflow prediction tool helps water resource managers have access to the data they need, all combining data collection, terrain processing, all in one thing, so they can focus on data collection, focus on decision making and preparing for flood events.
And this kind of information can be incredibly valuable to both engineers and decision makers. I'd like to discuss 3 specific ways this information can be applied. The first is some historical information. This hydrograph pictured is like the one you just saw in the video, except you'll notice on the x-axis, instead of going 15 days into the future, it shows 35 years worth of historical information. This is generated more or less the same way as the forecast information. Again, taking advantage of the global sources of data available for meteorology. Going back 35 years into the past, we have historical data and can produce those same runoff grids that is processed, routed to streams, and turns into Streamflow, produces this hydrograph. This is very valuable for retrospective analysis. Knowing when and where and how much those questions for the past helps us for the future as well by providing context. You can analyze well-documented floods with the simulated stream flow that occurred during those same periods, helping you understand if a certain flow is going to cause damage or what kinds of things you should expect. The second application of this data is a piece of software developed as a collaboration between Brigham Young University and INDRI, which is the Water Resources Department of the Dominican Republic governments. The tool provides a series of simple interfaces like this one pictured. The application draws the predicted streamflow values from the Streamflow prediction tool and puts it in this table, where the user can then specify how much water they expect to use out of their reservoirs. Then using bathymetry information, the app can calculate differences in elevation just by using the predicted streamflow values and the predicted outflow values. Last is an application used for flood mapping. Engineers are really used to seeing graphs like this one, the hydrograph, and that shows you flow versus time. However, it can be very difficult even for an engineer that's familiar with this to turn it into something practical that a decision maker can use to prepare. This is a flood extent map that will show you the boundaries of where flooding occurred. This application works very similar to the Streamflow prediction tool. You start by just picking an area of the world and the dates of the forecast that you would like to analyze. Then you zoom into the area of the map that you're interested in. This time when you click on the stream, instead of getting those same graphs again, it uses the global elevation data and the other satellite data that we have available to produce an animation that shows where flooding will occur versus time. This uses those same predicted streamflow values as the tool shows on the hydrograph. Additionally, since there are 52 different estimations in the ensemble, there's uncertainty in what we do. The tool also plots a similar animation, this time instead of showing where the flooding will occur, showing the probability of experiencing flooding within those extents versus time. So where does that leave us for Cuba? We have the Streamflow prediction tool. This has already left its research and development stage and is now housed by the European Center for Medium Range Weather Forecasting. The information is available every day as soon as the runoff grids are computed. Additionally, there are the derivative applications like the ones I've shown and as many as 20 others. These are available for free. Most importantly, engineers could start using this today. You don't need subscriptions, you don't need technology, you don't need anything besides a computer that can access the internet. This is readily available as a web service intended to help decision makers. In the future, we propose a partnership between Brigham Young University and Cuba, thereby connecting Cuba to the larger international community that works towards sustainable water management. As the original developers of this tool, we can give you the capacity to use global models. We can show you the benefits, train you in the software and how to access the data, thereby enabling you to save time and money and lives and infrastructure and things that are going to make a real impact in the day-to-day lives of Cubans. By forming this partnership and joining the international community, Cuba can become a player in the fight for a sustainable world. Those sustainable development goals can't be accomplished by the United States alone any more than they can by Cuba alone or any individual country. This collaboration and teamwork will lead us towards that. We believe that by sharing resources and everyone being a part will lead us towards the sustainable water management and sustainable world at large. Thank you.
Thank you. At this time, we're going to open it up for questions from the judges, and they'll have 10 minutes to discuss the previous written section and/or the presentation today. So you can go ahead.
Good morning. Thank you for your presentation. I have a question. You wrote here Cuba is able to use the hydrologic network to obtain water level data and safely evacuate cities and towns before major flooding occurs. My question is, how is your tool actually, whether it's working together with the manual gathered data, or is it separate, completely independent? And I understand it's a stochastic model, and model has some predictability based on some assumptions, while this is real data. So how do you, how will an engineer actually, or a scientist actually evaluate the real data versus the model that you provide?
That is an excellent question. With this model, the idea is to supplement the data available. Using measured data along with these models can help you have a better picture. The idea with this model is that, especially in areas where there's not that ability to take that data, they can get a better idea of what's going to happen. Also, the predictability of being able to see 15 days into the future can give an idea of where there's going to be, there could be a flood, and then if you want to, you can go take more measurements to be sure.
Just to add on to that, if there is no historic data available, it could be very difficult for an engineer to know how to predict if the flows they're going to see are going to be above normal or they're going to cause damage. So by accessing this data that comes from tested European models and statistical meteorology, they have the context to make predictions, and then they could use statistical distributions like the Gumbel method or other common practices to predict the future.
Additionally, BYU has also developed some statistical tools for comparing the forecast to observed data to help the people using it in that specific area to get a better understanding of how the forecast performs compared to their measured data.
So, great presentation. I happened to graduate from a university in Cuba, and I worked at the hydraulics department, so I can testify about how difficult it is to gather data, but it's happening. So my question is if, as my colleague mentioned, you are based on forecasting, but how do you actually check that your forecast actually happened later? So how do you validate real data? So my question is, do you reach out to the institute that gathered this information in Cuba? Do you went further to actually confirm that this is happening? And then, as he asked, how do you match what they are doing and what you are proposing, taking into consideration that, I don't know if you know, but access to internet in Cuba is not that easy. So you are proposing a solution that is based mostly on internet, but how do you connect something that is really difficult to access to something that they're already doing? And if you go further to actually find a good solution or recommendation for the way that Cuba operates.
You want to take it?
Yeah, sure. Yeah, no, that's a great question. Of course, anytime you're predicting something, you need to know how good your estimation is. That depends on your assumptions and everything. So the Streamflow prediction tool can be somewhat tailored to specific areas. Cuba being an island, obviously is going to have different needs than the United States, which is a large continuous land mass. So having the measured data that, as you mentioned, is beginning to be collected around the country, you can compare the measured values with the predicted values, and then since the tool has left research and moved to the European Center for Medium Range Weather Forecasting, it can be tailored there and get better results over time for Cuba in general.
You reach out to the department that does that in Cuba?
We have not yet.
We weren't able to be in contact with them for this project yet.
Do you know who they are? Or which department?
No. We tried to get in contact through some of our contacts in the Dominican Republic and weren't able to.
You know, I have a similar question that Armando had, but let me adjust myself to how many countries are now connected to this system? That's my first question. And two, when these countries they connect to this system, which you said is through the web base, there is any specific expenditure that they need to go? You said it is connecting to the web base is for free, but is any investment within the country where they need to do in order to better provide you with the better results or better data, or how it has been in the past with the other countries that you know they are connected to?
Okay, so I'll answer your first question. We do a lot of work with the Dominican Republic. Additionally, in Bangladesh and Nepal, we are doing a lot of work with this specific tool. Okay. In terms of costs, to access the forecast, they wouldn't have, all they need is the internet. Now if they, depending on how much they want to understand how the forecast compares to their measured data, you'd have to go collect measured data and compare it. Because they're already collecting data, you could compare data there. It really depends on what they want to do. For example, this flood mapping tool, to apply that to Cuba, we'd have to get some more local elevation data, for example, to get the flood mapping. But that could be done with BYU as a partnership.
Okay, for example, you mentioned the Dominican Republic. It's a, how it's going, I mean, for how long you've been doing this with the Dominican Republic, and if you know is exactly what the data they are obtaining from them is really accurate, how much do they spend in doing that?
Yeah.
Because it's very similar to Cuba. It's in the same area. That's what I wonder why.
Yeah, that's a great point. The Dominican Republic is topographically and locations very similar to Cuba. The the research lab that we come from has been partnered with INJRI in the Dominican Republic for 10 years now, and every year we make a trip down there and we work with the people there. This is all, the students pay for it themselves as a senior project, so it hasn't cost them much, if anything. They just use their own computers that they already have, and they're looking into the possibility of developing more of their own apps and setting up their own servers, which would be an additional cost depending on exactly how they decided to go about it. But so far it's been just a free partnership for them.
Just following up on the same subject, what kind of investment would be required in terms of intellectual capital, in terms of coding, modifying computer programs from Cuban engineers, if you will? What access do they have to the model so they can tailor it to their specific needs? Is it something, you mentioned that you had partners at NASA, UN, World Bank, et cetera. While you guys contribute your own work, that may be free. I don't know, at NASA, World Bank, UN, anybody else, or UWCF, will be doing work for free. So assuming that Cuba were to adopt the system, if you will, what would they need in terms of intellectual capital and also dollars associated with modifying the program? Is that something that they can do themselves, or does UWMCF, or I can't remember the acronym, that's something that they need to do and it has a cost?
Yeah, so as someone who has less experience than these two with the app, just to use the app, it's very straightforward, and you really don't need much more experience than just a general knowledge of computers. To get in, to actually, with the way the applications are housed, it's fairly simple to go in and create your own derivative applications. You would typically need a basic understanding of computer coding, but no more than a couple classes to be able to effectively start to build your own apps.
Just to follow up, the initial research grant that funded the development of this tool had the express purpose of lowering barriers, these kind of technical barriers that you're getting at between the decision makers and the engineers, and being able to do predictive models and access the tools they need. So there's actually the apps that we showed you in the videos and the screenshots were developed from a platform that came out of that. It's very well documented, and it's already been developed such that people that don't have the coding experience that you're describing have a variety of tools, and it's intended with, it was designed for those people in mind.
One quick question, a yes or no question. Based on this tool alone, will you evacuate a city if it predicts there's going to be some flooding? Will you have enough confidence that just based on this tool alone, will you cause 5,000, 10,000 people to move from there? Yes or no?
Are you referring to the flood mapping thing?
To the tools that you're presenting.
I would say yes.
What about you?
I would say that it would be wise to compare to data and see how, and then you can figure out if there's bias in the forecast.
Just based on the tool?
Just today.
Yes. Will you use this tool to evacuate and move 5,000 people out of the city?
I don't think so.
Okay. Thank you.
I would agree with Chris, not just with this tool.
Thank you very much. Very honest.
We still have a little bit of time left in their question and answer session if there's any other questions from the audience. Yeah? Hold on a second.
Former professor, but
This is for
I was with Duke University. Is this on?
That's the thing. It's not going to be audio.
Oh, okay. So anyway, my question is, what are the underlying mechanics in this model? I figure it probably uses some stochastic tools like extreme value distributions, log Pearson, and so forth. But what about the flood mapping? You need to have some mechanics in routing so that you can get the lateral extent. So what are we talking about here? Dynamic waves, kinematic waves? Do you know what the details are?
So for the Streamflow forecast, it uses a model called RAPID, which is a river routing model. And for the flood mapping, it's a method known as the hand method, height above nearest drainage method.
Okay, thank you.
My question is directed more about the real-world application of the model. I mean, it's a great model, and I commend, your university for kind of enhancing it. All good. Another thing is, or another way to look at it is, so I want to develop a solution to evacuate people in case of a flood, right? And so this is the answer to that question, as opposed to here's a great model, go use it. So the question is, did you give any thought to the real world applications of the model? Maybe this is the same thing that that was asked a minute ago in a different way, but a real world, how do I use this model to answer a question that is real world? Did you give any thought to that?
I would say for real-world application, it would be important to compare the model results to measured data to get an idea of any biases in the model and seeing what kind of results you're getting. And then you'd be able to use the results and understanding what they're giving you relative. You can have a confidence in what the results are giving you. There are various ways to access the results for each stream that can be automated, that a user could automatically see the results of whatever streams they're interested in. They don't have to go into this tool directly. There are ways to do that they could get the results for the river they're interested in every day.
Right, but I think I'm trying to guide you to what question are you trying to solve, other than here's a great piece of technology and here's a model that gives you some really, really good information. That's great, but what question are you trying to answer? What problem are you trying to solve, right? So it could be, I want to evacuate people, right? I want to preserve, my manufacturing plants, right? That's the kind of solution, right? You've talked about the model. We understand the model. It's a great model, right? And by the way, these guys are far ahead of where NOAA is, et cetera. We all, have great things to say about them. But did you give some thought to the answer or the question that you're trying to answer, as opposed to this is a great model?
So I guess a couple of the questions that we brought about is, what is the extent of the flood going to be? Or we also showed the application for reservoir management. What is the reservoir level going to be? How should I manage this reservoir? How much should I let out? Things like that.
And additionally, that's what we would hope to be able to better address in a partnership between Cuba and the international community, is we've developed these global models that provide you the foundation that you need to answer specific questions. But a global model can't, global models can't answer every question everywhere. There's no model's perfect. So we would address specific needs as in the application phase.
When you mentioned that you had an annual historical data, is that available for Cuba, or is that only available for certain parts of the world?
So the historical data we showed is available everywhere. It is a simulation based on the European model's retrospective meteorology.
So it's historical simulations.
So
well, we would have forecasted for, if we have forecasted for a year, we go and take a look back, and this is what my forecast was for the last year. But it's not actual data.
The historical data we're showing is more of, they use all the global records they have of meteorology and then produce kind of the same forecast, but in the past. So this can be valuable in areas where there's not measured data, and where you do have measured data, you can compare to see.
And do they do it globally, or do they do it by watersheds? Or
it's globally.
Global, okay, thank you.
Thank you so much. Let's go ahead and give Chris and his team a great round of applause. Thank you. Moving forward, we're going to be welcoming to the stage the George Mason University team. This team is led by Sherwin, and he's going to be presenting on developing stormwater for resilient Old Havana through the use of green infrastructure?
Hello? Hello everyone, I am Sherman Zahira. I am a graduate student in Environmental and Water Resources Engineering at George Mason University, and I will be presenting on how to develop a flood-resilient Havana. Are green infrastructure practices feasible? To give an outline of my presentation, I will give an introduction to the study subject, my methodology for tackling this problem, and the results I came up with, and future objectives. So, from recorded history up until now, Havana and Cuba as a whole has been victim to several significant flood events. Irma, Alberto, there was a recent tornado a couple months ago that all bring about heavy flooding. And this flooding causes a lot of infrastructure damage as well as harm to life and people. And as a result, significant economic damage and infrastructural. So the objective of the study is to evaluate the potential of green infrastructure implementation within Old Havana to reduce the quantity of stormwater runoff. To give a basic hydrology background, urbanization is directly correlated to an increase in stormwater runoff, and this runoff leads to increased flooding and pollutant loads. If you look at this diagram, you see in natural ground cover, meaning there's been no development on it, 50% of the water gets soaked into the ground, 40% of it evaporates back into the air, and 10% becomes runoff. But when we urbanize an area, there's nowhere for that water to permeate into the ground. So therefore, most of that water becomes runoff. And we quantify the surface runoff through something known as a rational method, it being the product of the rainfall amount, a land use coefficient, which is dependent on the type of ground that our rainfall is hitting on, and the area of interest. In addition to rainfall, we also have storm surge, which also presents heavy damages to coastal communities. And this is a result, this is due to water rise from air forcings due to hurricanes, in addition to current tidal situations, as we see through this diagram. And storm surge usually will go over seawalls and barriers and inundate buildings and a large area of Havana. Climate change is predicted to increase both the rainfall intensity and frequency in these high-intensity storm events. And current infrastructure right now is not resilient to these storm events. Resiliency meaning the infrastructure and the community's ability to bounce back as a result of a storm and reduce financial, economic, and financial, infrastructural, and life risk. So there's a necessity to adapt to this predicted increase in rainfall intensity and frequency. And in order to do this, I propose implementing more green infrastructure initiatives. As you can see through this diagram, there's a hydrograph that depicts post-development conditions. You see the high peak flow as well as at a shorter time, meaning more flash flooding, as compared to pre-development where we get lower peak flow and further time to that peak flow. And traditional methods reduce the stormwater quantity, but still more flooding occurs. So the goal is to use green infrastructure initiatives to reduce the amount of volume and the time that it takes to achieve this peak flow. Green infrastructure has been heavily implemented into developed countries, the United States, Europe, but it has not seen much implementation yet in developing countries. And for this study, according to as said by the World Bank, Cuba will be considered a developing country. I found two studies that studied the potential of green infrastructure in developing communities, one for Tanzania in Africa and one for Peru. And the main point that those studies portrayed is that it is necessary to adapt green infrastructure development practices for varying cultures, economies, and technical capabilities. The engineers over there don't have as much resources, technical and financial, to develop the green infrastructure initiatives that we do in more developed countries. So being able to adapt for these developing countries is an absolute necessity. The types of green infrastructure methods that I will be discussing are green roofs, bioretention cells, also known as rain gardens, permeable pavement, rainwater harvesting, and natural shorelines. The study site that I will be looking into is Old Havana, a 1.60 square mile municipality within Havana that was settled back in 1519. And it holds significant cultural and historical value. So the goal is to be able to make Old Havana more resilient, more sustainable, while maintaining its cultural integrity. The model I used for this study is a SWIM-5 developed by the United States Environmental Protection Agency, and it uses inputs such as rainfall, land cover, and watershed characteristics to model the study site's hydrology. There is currently no freely available live rainfall data for Havana, and a study that I came across used a storm recorded at the Miami International Airport in 1979, and through various statistical analysis, we can use that design storm as the 100-year design storm, which is typically used for engineering analysis. And by 100-year design storm, that means a storm that has 1% chance of occurring every year. In addition, a climate adaptation tool was used within the study to develop a predicted design storm for 2079, given the predicted increased rainfall. So if you look at this hydrograph, you can compare the rainfall amount per hour for the design storm, and we see a 17%, by looking at the peak value, we see a 17% increase in rainfall quantity within, between the current design storm and the 2079 predicted storm. So, and this hydrograph used for the entirety of Old Havana, comparing the current design storm and the 2079 predicted storm, we see a 35% increase due to climate change and surface runoff. Drainage conditions using visual analysis, the current percentage of imperviousness within Old Havana was considered to be 90%, and my goal is to reduce this to 45% as a whole using green infrastructure. And by comparing the present, for the current design storm, if I implement that 45% of green infrastructure, we see a 27% decrease in runoff due to the implementation. So what I did is, using Google Maps to look at various areas within Old Havana, I located several areas where I believe, through an engineering and landscape architect point of view, that these initiatives can be implemented. And then within that site, I used SWIM to model the runoff changes, as well as using an LID cost tool by the Water Environmental Research Foundation to determine the cost of implementing those proposals. So the first method I'll be talking about is a bioretention cell, as we see here. And how these work is that rainwater goes into this garden and infiltrates within the soil and the planting, and instead of turning into runoff, it recharges groundwater, and then that extra runoff that the groundwater can't hold gets released into the storm sewer system. So, and here we have Plaza Vieja. I determined a steady site area of 45,000 square feet, with the 2 black circles representing 2 bioretention cells. And by implementing these 2 bioretention cells, we get a 30% decrease in runoff. Within these hydrographs, please ignore the stepwise motion of the current conditions. It's something with the Swim 5 software that I couldn't fix, but if the peak value still holds for comparison. For the 2 cells, we get a $4,600,000 cost with a $160 per year maintenance cost. So over 50 years, we get a $59,000 cost, with the benefits being reduced stormwater runoff, increased better water quality, as well as an increase in aesthetic to the plaza. A lot of green infrastructure isn't meant just to mitigate stormwater effects, but to add aesthetic value to the area of interest. My second proposal is permeable pavement, as we see here. It looks a lot like your standard pavement, but instead of water turning into runoff, it infiltrates within the pavement through the layers and recharges the groundwater, and with the extra draining into a stormwater system. Looking at Plaza de la Catedral, we have an area of 13,250 square feet with 100% imperviousness. And to replace all that with permeable pavement, we get a 70% reduction in runoff volume. This costing $17,500 with an annual maintenance cost of $250 per year, totaling over a 50-year period, $24,000, with benefits being mitigated flooding. Green roofs, what these are is, rather than having typical roofing for a building, it's more vegetated roofing. And what this does is it captures storm water, and it also provides insulation to the building, which reduces energy costs, and as well as providing an aesthetic value to the roofing of a building. This has been used in many hospitals, like I proposed here, where the patients can go out and enjoy the green scenery. So by implementing the Swim 5 model, we get a 60% reduction in runoff volume. With a large cost of $585,000 and a $1,400 annual cost, totaling $662,000 over a 50-year period, with benefits being mitigated flooding, reduced energy consumption within the hospital, as well as an increase in the well-being of the ambience of the hospital. Rainwater harvesting, using cisterns and barrels to capture rainwater. To connect to a building, I connected to the hospital previously mentioned, and to capture a 2-year storm off the roof, I had to develop a 16,000 liter gallon with an estimated cost to implement of $47,000. And Havana currently struggles with water availability, so this would be able to use water to capture for gray water purposes, leaving more for drinking. Natural shorelines, like this one shown here, although I didn't model, are essential to protecting coastal communities from storm surge. As storm surges go into land, if we have these mangroves and wetlands, they provide friction to the storm surge, and then this, as a result, reduces the amount of height within the surge, which then reduces the amount of risk that a storm presents. El Malecon is an area with a seawall that hasn't shown to been resilient enough to storm surge events. So by adding this, adding natural shorelines there and restoring them, the seawall and the natural shorelines can work together to reduce the amount of surge, as well as contribute to a healthier ecosystem. So to conclude, green infrastructure has demonstrated to be an effective method for mitigating stormwater-related issues, and implementing them will increase resiliency to storm events. And these practices should be implemented through a long-term watershed management plan over the next several years as Havana continues to grow and redevelop, to slowly implement these plans, as well as to promote interdisciplinary collaboration between engineers, landscape architects, and stakeholders. Community involvement is essential, and to use public meetings and town halls to discuss ideas with the people and to promote volunteerism to involve community and reduce costs. Topics for future study include coastal storm surge modeling to exactly evaluate the amount of storm surge, water quality modeling, how to promote effective communication methods, and how to promote interdisciplinary practices to implement green infrastructures in developing communities. Thank you all for your time, and any questions?
I got a very good presentation.
Thank you.
And what I really like about your presentation is that you're being very, very specific in terms of selecting the area, and definitely this is the most exposed area in Havana, no question about that. There is one aspect that you discussed in the technical report, and I was hoping that you discussed it here, and you did at the very end, that you said that it is better probably to implement these new improvements or techniques in new developments.
Yes.
And I have an idea how you do that, but I would like you to ask you how do you, if you were to make a recommendation, how would you implement that?
So what we see here a lot in the U.S. is a lot of counties and communities implementing what they call watershed management plans, and within these plans they provide recommendations for the next many years of development and how to design to most effectively benefit the people as well as the stormwater quantity and quality. So as future developments are being made and these renovations are being created, we can slowly implement these practices. So in the next 100 years, you'll start seeing more green infrastructure areas pop up throughout the community.
Well, I would tell you that probably not. The best way to implement this is through the building permitting process. So when you go and apply to, in this case, in this municipal government in Havana, then it will be part of the requirement of your development that you implement these improvements. All right?
Great, thank you.
I noticed that in the bioretention cell that you showed here, you had it tied to the stormwater system. The one that you had in the paper was not. Is that a requirement that it work through the stormwater system? Because I don't know what the state of the sewer system is in Cuba, whether it's in complete disrepair and tying it to it will make things worse or not.
So an assumption that I made within all my developments is that the designs work within the current layout of the area, because I didn't have specific site plans to know where the low points were and where the storm sewer networks are currently located. In terms of the current state of the storm sewer system within Havana, I did not look specifically into that. But yes, they will be connected into the storm sewer system so that any excess water within the material has a way to leave.
Okay, yeah. A couple more questions. One related to the green roof that you were putting on the hospital.
Yes.
I am totally out of my expertise in here, but given the fact that you're going to be putting plant material on the roof, is that something that could cause health effects to the patient at the hospital? Has it been done anywhere else before? It
has been done, and actually, green roofs have shown to improve health within the building, and for it actually assists when applying for here in America LEED certification. If you have a green roof, that helps in improving the health of the building.
Okay. A question with your permeable pavement.
Yes.
I saw in the written materials that I have, it was a 40% void aggregate mix below the permeable pavement itself. Your cost for the pavement itself and the mix and all that kind of stuff appeared low compared to what I'm familiar with here. And how much maintenance is there associated with aggregate material that has a 40% void factor in it? I have no idea. I'm just asking a question.
To that specificity, I am not aware. But one thing that I quickly mentioned at the end is that in developing countries, when it comes to maintenance and these tasks that you don't need specifically trained people to do. Promoting volunteerism within the community in developing countries is a way to reduce costs associated with those, reduce labor costs associated with maintenance tasks.
So first I want to mention that you're attacking a real problem in Havana and you are proposing real solutions. So I'm really impressed, not just because for your proposing, but doing everything just using Google Maps. Wow, incredible you are able to do that using Google Maps, but you are suggesting real solutions, so you need to be real, you need to be practical. And I want to work with you over some practical things. You know, so you selected Old Havana. You know why it's called Old Havana?
Because it's the first settlement within
because it was
area.
built by the Spaniards 2 centuries ago. And it was considered by the UNESCO as a World Heritage place. Do you know what that means?
That there is a goal to preserve and...
Correct. So you need to preserve what you have in there. So let's take that into consideration for the practical things that you're proposing. So first, the bioretention cells. You are proposing to have that into a plaza. You cannot modify the plaza. So you need to look for green spaces. And I know you're using Google Maps, but you need to be practical.
Yeah.
You cannot modify the plaza because it's protected by the UNESCO. So,
okay. I wasn't aware that it was that specific to
Okay. The second one, the permanent pavement, or that you're suggesting. Do you know that Old Havana already have pavement?
Permeable pavement?
Yeah, all the streets.
Oh.
So probably Google Maps doesn't tell you that. And that was built by Spaniards 2 centuries ago. So I like your solution, but again, you need to think about practical. Do you know that Old Havana is right now being replacing all their streets? So this could be an excellent solution if you know what's happening in Havana right now. The green roof. First, you selected a hospital that is not in Old Havana. It's not. It's outside of Havana. And second, you are using a building that belongs to the government.
Oh.
And they're not going to have the resources to do that. So think about practical. What are the new buildings that are being built in Old Havana? Do you know?
No.
Hotels.
Hotels.
And they're massive.
Okay.
And they have money. So being practical, you need to think about the real solutions. Who has the money? International investors, hotels, and they're building. So great solutions that are happening in Old Havana, and they're massive in terms of construction. And then the natural shorelines, yeah, I'm sorry to tell you that the Malecon cannot have natural shorelines. So again, I think that you are proposing solutions, but you need to be more knowing what is happening in the area that you're suggesting.
Okay. Yeah, thank you.
Obviously, you had contacted him first.
Actually, I second some of the things that were said here. I think your solutions are great, perhaps not for Cuba, but they're great for many reasons. One of the things, for example, the permeable pavement, actually it's called cobblestones, okay? And I don't know why it was removed, because I grew up with the street with cobblestones. The water went in through it. It was beautiful. And it did two other things. It reduced the traffic, the speed of the traffic, because it was bumpy, and it added a lot of flavor to a city. And going into a city like Antigua, Guatemala, where it's completely cobblestones, it's magnificent. So it really accomplished what you have. Perhaps that also increases the amount of labor that is required to do things like that instead of having a machine doing it. The second thing is, regarding the roofs, you have to, when you add the green roof, you need to plan from when you build the building to actually have the structure to support the weight. You can't put a swimming pool on top of a building just because, okay, well, we have a roof. The amount of weight, the structure has to be designed from the ground up to support that. So in principle, it's great. But I don't know if it's really applicable to any existing building that was not designed to support that kind of weight. Third, regarding the water runoff, you have in Bermuda, they do that in order to accumulate the water from rainfall, so they have cisterns. And many places they have that. You go to Masada in Israel, they have it. They have it in many places. It's an old way of doing it, and it's great, especially to hold runoff. But unfortunately, when you have like hurricanes, and we live in Miami, so we have quite a lot of experience with that, the amount of water runoff, it's impossible. However, I happen to live in Coral Gables, where there are no sewers, believe it or not. It's the very most expensive city, and there's no sewers. So we have this holes that are not connected to the sewer system, but allows for the permeation of water that will go from rain into and will actually accelerate the amount of absorption. And finally, I dispute one thing you did, this association with Miami International Airport. That's inland, and we have a natural barrier called Miami Beach. I mean, we have a whole thing, and the airport is far away. If you would have chosen Key West, I would have said, okay, it's exposed to it. But Miami International Airport, I don't think it's a valid model. But overall, I like your presentation, and I think the solutions may not be applicable to Havana, but I'm sure this is applicable to many, many other areas, and congratulations.
Great, thank you very much.
Thank you. Let's give it up for Sherwin and his team. At this time, we're going to move on to the next team, which is the Georgia Tech Institute of Technology team. I wanted to take as they are coming up, I did want to mention a couple of things, and I think the fact that we have so much experience, I think, with our judges and actual feedback directly from Cuba is really exciting to see that here today. In the past, I think we've been able to look at the engineering side and the actual application of these technologies and projects can be very well vetted, so we appreciate that coming in from the judges. So this team is going to be presenting specifically on the implementation of microcatchment systems in Cuban agriculture. So Ajay and his team have the floor.
Good morning. We are Yellow Jackets for Cuba, a team of first-year students from Georgia Tech. My name is Ajay Sukwani, and I'm pursuing a bachelor's in mechanical engineering.
Hi, my name is Kinara Banda, and I'm pursuing a degree in material science engineering.
Hi, my name is Varnita Prakash, and I'm pursuing a bachelor's degree in aerospace engineering.
Hi, my name is Duncan Siebert, and I'm pursuing a bachelor's degree in industrial and systems engineering.
So today we're going to talk to you about the implementation of microcatchment systems for agriculture in Cuba. As we get started, we want to talk about what the problem is. As we all know at this point, there have been a lot of extreme weather events in Cuba, starting with the drought. And at this point, about 43% of the territory has been affected, as of our statistics from 2017, which means 900,000 people are without sufficient clean water. This classifies as the second highest tier of drought, which is extreme drought. And with climate change, these extreme weather events are only going to increase in occurrence, whether that's drought or floods. And as this happens, agricultural water is scarce, and food and export production is low. You can see from our chart here, the PDSI shows the index of droughts over the years, and the red section on the end kind of shows the increase in frequency in the recent past. So the question we asked ourselves is, how might we provide Cuban farmers with an affordable, effective, and personalized solution during periods of critical water supply? Some of the things that already exist for the territory here kind of shows the crop distributions across the island. So you have tobacco, rice, and coffee that we focused on here that you can see are distributed across different elevations and slopes across the island. We wanted to create a solution that would be applicable for all of them, and that's what Kinara is going to talk to you about.
So because of the fact that the major crops, tobacco, rice, and coffee, are grown in different regions with different slopes and different soil profiles, we figured that the rainwater harvesting system of the microcatchment would be the most effective way, because it could be personalized and it could be customized for every different crop type and soil type, and also the slope. So a microcatchment system is basically a contoured area with slopes and beams, and what it does is that it increases the runoff collection from the rain and stores it in the soil profile. The length is generally between 1 to 30 meters, and some of the advantages of a microcatchment system compared to other rainwater harvesting systems is that it enhances even plant growth, and it's easy to construct given the length is between 1 to 30 meters. And it's not site-specific, so if the terrain is irregular, it can be constructed around it. And it also maintains the saline balance, maintaining the soil fertility. So there are multiple types of microcatchments, like the negarim, the contour bunds, the semicircular bunds, and the contour ridges. And depending on the slope, the crop type, and the soil type, they can be selected for different crops. So the process of selecting an optimal microcatchment system, we require the slope to be less than 5%, and the infiltration rate of the soil to be less than the rainfall intensity. So what you see here is a basic flowchart that helps us to determine the optimal microcatchment system for a particular crop type, soil type, and also a slope. We also consider various social economic factors because we want a personalized solution for the farmers to use. And so what we require, the participation of the farmers is also a really important factor. The adoption of the system, the ease at which these systems can be adopted and implemented, and also the area differences is also what we look into. So after we determine the optimal microcatchment system, we also need to find out the microcatchment size, because the difference in the annual rainfall and the water requirement of the crop helps us determine the optimal microcatchment size in order to maintain or cope up for this difference. So the main data that is used in determining the size is the hydrological data, which includes the annual rainfall, the terrain properties, etc. The soil infiltration data, and the runoff coefficient, which is specific to every soil type. The annual rainfall of that particular region, that's the terrain requirements. The other crop requirements that we also incorporate is the crop water requirement, the crop factor, which includes the transpiration and the evaporation from its soil surface and from its leaves, and also the reference crop evapotranspiration.
So as for our initial implementation, we're looking for two important factors when we were deciding on focusing on central Cuban rice farms. The first was which crop would be the most benefit from a microcatchment system. So we looked at what different water requirements are for crops, and because rice is the type of plant that requires constant sitting water or stagnant water, we felt a microcatchment would be extremely beneficial in this specific field. The next thing we did is we looked at what areas rice is grown in throughout Cuba. We found that they're grown in the central part of the island as well as the left and rightmost points. The problem with the left and rightmost points is that those are very mountainous regions, so it's a little more difficult to achieve this 5% gradient, whereas the central region is more of a flat field. So we found that the labor cost for implementing microcatchment here would be extremely easy and very cheap and effective, which is why we chose this as our initial stage. We plan on using a variety of sensors and drones to take our moisture and topography calculations. And what these sensors and drones will do is gather all of the different coefficients that we need to develop the ideal microcatchment system for the farmer, so that the farmer can then decide, or at least know what microcatchment system they would need to set up in order to increase their rainwater collection. And we plan on outsourcing that using big data analytics so that we can model it for a variety of different crops throughout the island. And we actually spoke with the CEO of Civotech, a data analytics company, to discuss the feasibility of implementing our software and algorithm. And we found that it can be done at a relatively low cost and with a fairly high amount of success. So here we have a very basic layout of what our final product would look like. On the top, the only inputs by the farmers would be the crop, the location, and the soil type. And then it would have all of the data analysis here on the left side, which the user or the data analytics company can use to verify that the software and algorithm is all running up to par to whatever the reality is in their situation. And the image would show a basic diagram of what kind of microcatchment system would be ideal for their scenario, along with a basic description of the ideal microcatchment system and the area that they would need.
So now we're going to move into the cost analysis of our solution for a second. And the first and foremost cost is, of course, the database, the development of the algorithm, and the analysis of the data collected by the probes. And this will be outsourced, of course, so we can take advantage of existing human capital and fixed factors of production. And for our initial pilot project, we have a quote of around $5,000. And the next factor would be the implementation cost of the microcatchment systems, which would be monetarily non-existent, but would involve some amount of labor from the farmers. The maintenance cost is similarly non-monetary and may just involve small amounts of labor by the farmers. And the probes themselves may cost from around $150 to $550 based on quantity and quality. And the same goes for the drones, which range from $3,000 to $5,000. Now, the farmers have to access our app or web app through some sort of platform. And the most recommended platform would be a mobile phone, which, looking at the lower end of the spectrum, would range from $60 to $100. Although they could also easily use an internet cafe or a laptop if they had access to one. And this brings us to our next point, internet infrastructure in Cuba. Since 2018, actually, mobile internet has been available in Cuba, but is prohibitively expensive, so that farmers would not be able to afford it. However, we're hoping to partner with the Cuban government to perhaps subsidize or even provide freely internet to farmers partaking in the pilot program. And so this brings us to a total cost range of $8,210 to $10,650 for our initial pilot project. But it's important to keep in mind that the drones, for example, is an initial fixed cost that can be reused, and the same goes for the probes. And to some extent, much less data analysis will be required after the initial period of time in which the algorithm is developed. So the $5,000 are not some sort of steady fee that has to be paid over time. So now we're moving on into the economic impact of our solution. It will increase food security, which is, of course, an indicator of human development. And in many cases, increased food security leads to increased economic growth. It will also decrease soil erosion and maintain a balanced soil fertility, which will increase the quality and quantity of the crops grown by farmers. And it will have initially it will have a great effect on imports, as Cuba currently imports around 75% of its agriculture. And so by allowing Cuba to grow more rice and other crops on its own, it will reduce the trade deficit and enable it to become more self-reliant. And if our project scalability succeeds, we can also scale it to tobacco and sugar, which are some of sugarcane, which are some of Cuba's major exports, leading to increased export profits and, again, a decrease in the trade deficit. It will also result in less reliance on irrigation systems, which will allow Cuban farmers and the agricultural industry to weather extreme weather like droughts more efficiently.
So to sum up our overall idea, we want to implement microcatchment systems throughout Cuba. We came to this solution because we found microcatchment systems to be a very cheap and effective form of increasing water retention in places that are affected by severe drought. In order to kind of innovate and revolutionize the implementation of microcatchment systems, we hope to use topographical and hydrological data to scale the project, not only by giving farmers a model of what they should implement in their system, but to scale it towards multiple crops and multiple locations around the island. And in order to effectively do that part of our solution, we plan on using big data analytics as well as AI to model the different scenarios throughout the island of Cuba. And as far as future plans, like I mentioned before, we want to increase our scale. One thing to keep in mind is that since we are using AI and machine learning, this algorithm would continue to improve upon itself as it gathers more data from different locations on the island. And by continuously improving, it would provide Cuba with a continuous return on investment, and it would provide it with an increasingly perfect solution or increasingly perfect model. And we also want to increase the ease of access of our user interface and make it more intuitive for farmers, because we know a lot of these farmers might not have access to the amount of technology that we did as kids. They might not be as sophisticated or tech savvy per se, so we want to make sure our platform is very easy to use.
We'd like to thank Dr. Jeffrey A. Davis, who's our faculty advisor at Georgia Tech, as well as Pete Martinez, who is our advisor from CISC. We will now be taking any questions.
I'm glad to see that you, in your written report, you did not include the dollar amount. I don't think I didn't see anything of that. And now you went over and can you be more specific about you mentioned a pilot project. Can you be more specific at what a pilot project would be and how do you be accomplishing that and the data that would be obtained and how that data would benefit you for implementing in any other locations?
Sure. So the way a pilot program would work, and this is fairly common amongst data analytics companies, you would go in and you would tell them your initial factors, what you want to get out of it. The pilot program would be for the central Cuban rice farms. So we would take one specific rice farm in central Cuba, and that would be the initial $5,000 cost. And then once that whole algorithm is developed for that one farm, we can then scale it up outwards. But it is important to note that the cost for implementing it in other farms would be progressively less and less because as we get more and more data, we don't need to collect as much for our solution to be implemented.
At this moment, how much of a production increase would you estimate that would be obtained after implementing this rice? Or is more than a preserving or increasing the production?
It's meant for increasing the production.
Okay.
And increasing Cuba's independence on crop and food staple reliance.
Okay.
Yeah. So additionally, the fact that the microcatchment results in, I think, 330 milliliters of the required millimeters, of rain of the required 714 millimeters for rice being accumulated and efficiently used. So it just means that Cuban farmers will have to use a lot less irrigation water or water, that actually costs them any sort of resources or money.
Okay.
And kind of just to add on to that, most irrigation systems that are in place right now require a lot of manpower and skill to be able to implement the pipes and the drainage systems and everything. And this also changes the salinity of the soil, which makes it less fertile for crops later on. The good thing about a microcatchment is it's very natural. So you're contouring the land as it is. You're not changing the composition of the soil, and it retains its fertility. So the fertility of the soil and the amount of crop production doesn't decrease as a result of whatever new irrigation that we have. So that's one advantage of our system.
Basically, what you propose is to have reservoirs or open cisterns adjacent to the fields where the crop will be planted, let's say in this case, rice. So, but rice has been imported by the Spaniards from Asia. Perhaps rice is not the best crop to plant in Cuba. And assuming, if you have this fixed idea that you need to have rice, because actually it became a staple of the Cuban diet, but that is because the Spaniards brought it from Asia. Perhaps we should have something else. And Cuba has two extremes. It has this amount of rain coming from all these tropical storms on one side, and then the lack of it. So wouldn't these open reservoirs be flooded in any type of rain, and then the soil will be absorbing most of it or evaporating before it could be used?
So our initial plan didn't include the cisterns, but it could. The point of the microcatchment system is that the collection is not the only part that's important. While it's running off, the water table also rises in the water under the soil. So the profile of the soil has been adjusted now. So it kind of naturally absorbs a lot of the extra water that you're talking about happens from floods and tropical storms.
So it'd be more like for a flood prevention type of situation, be at least flood regulating type of element.
It helps with soil erosion, but not flood prevention specifically. This is just to kind of redirect water so that it doesn't collect. It can help with flood prevention as a side effect, but we were talking about it more in terms of production and clean water required to produce the crops.
And just to comment on what you said about the rice, The reason we looked at rice is because we found that it was a very important staple. Rice and beans is probably one of the most common Cuban dishes. It's something I grew up with a lot as a kid. So we figured if we could increase, say, rice or bean production, we could have the greatest impact in feeding Cubans. But it's very possible to switch to a different crop if, when, say, going to Cuba and investigating the situation further, we found that something like tobacco or sugarcane would be more feasible.
Yeah, like in Uruguay, everybody drinks mate, and it doesn't grow there, so it's imported. Yeah. So it could be, the rice would be imported for where it's more efficient, and something else that is more appropriate for that thing, from that land.
Right. Rice is only our initial pilot project, and through the algorithms and the big data analytics, we're hoping to expand towards other crops. But we can start with a different crop if it's more suitable.
So, why exactly do you need the internet?
Sorry, can you say that?
Why do you need the internet? Why do you need this connected to the internet?
The farmers need to upload the data that they've collected, that the probes have collected from their farms, in order for it to be analyzed by our algorithms.
So you're planning to have the algorithms probably on the cloud doing the job for the farmers, right? But again, being practical, there is barely internet in Cuba, and farmers don't even have access to signal to talk on a cell phone. So how can you propose a solution to someone that doesn't have access to internet at all?
Yeah, another option is to have the server or the data run on the island. The reason we went with internet is because we know that a lot of data analytics companies are housed here in Miami, and we found that if we could find a place with access to internet, that would be the easiest way to run our initial pilot program. But it would be possible to have a server housed in Cuba to make it easier to transmit the data.
If you want to be practical, if you want to give a real solution, you need to think about real problems. And having data being transferred from Cuba to the United States is actually not possible. And no one in the government is going to welcome that. So you need to think about how can you give the resources to the farmers so they can analyze data and have the result right there, not even waiting for someone else to send the result back and what to do.
Yeah, another thing we could do is once, having an algorithm set up, we could have that essentially embedded into the program so that it runs right off of the farmer's laptop or something of that sort.
One of the things that I saw in the written paper was that you expected the farmers to provide the data, if you will, and that, I'm assuming that's through the use of the sensors that you're proposing. Farmers are by and large in Cuba anyway. They're humble, not necessarily highly educated people. So is there anything associated with the use of the sensors that would be difficult for them to do? Or is it something as simple as they just install a probe, et cetera? And second, also related to that, who will be running these drones and what would the drones be doing? Just getting data from the sensors, et cetera?
Yeah, so I was actually going to start with the drones. Flying the drones might be the most complicated thing, I would say. If a farmer were not skilled enough, then we would need some sort of person who is more tech savvy. As far as probes, there are probes that you just stick in the ground and they give out sensor data. For example, there is one that'll measure the, how arid the soil is, and that's just a matter of putting it over whatever plot of soil you want to examine and letting it run.
A lot of the sensor data as well is already available. Some of the groups before us actually talked about it, especially for salinity. That's very easy to do. There's already collection points in place in Cuba at the moment that takes care of what the soil profile looks like and what the standing water level is. If you've heard of the hand method, which is the height above the nearest drain, there's a lot of things already in place. So what we're suggesting is not that we install a whole bunch of new sensors and start from scratch. It's to already use the data that we have and kind of implement it and use it to perfect this microcatchment system that the farmers will be able to use. So a lot of the data they don't have to personally provide. It might just be where am I located geographically, what's the aridity of my soil, and what's the salinity. And that's like two simple sensors as opposed to them having to fly drones.
Okay, the cost of the data low cost, if you will, for data analysis, but for Cuba, they're still significant. Are there any other companies that can do this data analytics, or is it limited to this one company, or is this just one sample that you guys had?
No, this company, we actually just spoke to them to see what it was like, what the cost range was like in the industry. So we can vary various different companies to see if there's anything that's cheaper. We just wanted to get a rough estimate so we could decide whether or not this was potentially feasible.
Thank you. Thank you. At this time, we're going to take a 5-minute break and come back here at 10:45 to resume the live webcast. So we're going to take a 5-minute break to stretch, and we'll be back here in 5. Thank you. Okay, we're going to go ahead and resume the competition this morning. We have 3 more teams that are excited to present their projects. Up next, we will be having the Illinois Institute of Technology. Following them, the Florida International University team. And then we will be concluding with the University of Florida team. Like I mentioned at the beginning, we will be reviewing, the judges will be compiling the scores from the top teams in the ranking with respect to the written and the oral presentation. We will resume after lunch at 1 o'clock, and then we will be awarding the top 3 prizes for today. So at this time, without further ado, we're going to welcome the Illinois Institute of Technology team. They will be presenting specifically on transatlantic water engineering solutions, and specifically on the Almendares River. And leading this team is Jorge and Matt and Ivan, and I'll leave them to it.
Hi, everyone. My name is Ivan Leonard, and I'm from the Technological University of Madrid.
I'm Jorge Huarga, and I'm from the Illinois Institute of Technology.
And I'm Matthew Elstrom from Illinois Institute of Technology as well. Our project's on the cohesive solutions for contaminant removal and prevention in the Almendares Basin. Our main objective is to implement cost-effective, innovative treatment solutions to improve the quality of the Almendares River and the Ventura Aquifer, and that's what makes up the Almendares Basin. We will be doing our introduction, and then we'll talk about flood remediation, landfill waterproofing, wastewater networks, economic analysis, and then a conclusion. And I'll turn it over to Jorge for the introduction.
Hi, thank you, Matt. First, in the next slides, I would like to explain to you which are the main problems that Almendares River faces, which are the solutions that we propose to solve these issues. First of all, where is Almendares River? It is located in the north of Cuba, and it flows through the west part of Havana. It gathers the wastewater from several factories, neighborhoods, whose wastewater is not treated. So this situation leads to a very low quality of its waters. But this is not just the only problem. Approximately half of the population of Havana takes its drinking water from the Venta Aquifer. This aquifer is placed below the Almendares Basin, and both are connected hydraulically. What does it mean? That any pollution, any pollutant, any heavy metal that is poured into the Almendares Basin will filtrate and will reach the aquifer. And then when people from Havana take its drinking water, they will be also extracting all this pollution. And this is a real threat to their health. So there are many studies about the aquifer contamination, the pollution of these aquifers. And the main conclusion is that once an aquifer has been contaminated, it's really difficult, not just in money, but also in time, to decontaminate it. So the best solution is prevention. It's prevention before more than 1 million people will be enabled to take its drinking water from the Venta Aquifer. We have reviewed papers, articles, studies about the current situation of the Almendares Basin to understand the whole watershed. I mean, we didn't want to just focus in a single problem or in a single point, but to understand all elements in the basin, the factories, the neighborhoods, the different pollution sources. So we could propose several solutions to solve this problem. So we have worked mainly in three main solutions that are the ones that are there. But the first one is the filter remediation, the second one, the landfill waterproofing, and the last one, the wastewater network system improvement. Matt will start now with the first of these solutions.
Thank you. All right. So our first of three contaminant removal and prevention methods for the Almendares Basin is phytoremediation. Phytoremediation is used of living green plants for the removal, degradation, and containment of contaminants in soils, sludges, sediments, surface waters, and groundwater. A major pollutant of concern in the Almendares Basin is heavy metals. All heavy metals are toxic at high enough concentrations with ability to bioaccumulate as well. This stresses the need for removal from the water system. We'll use the phytoremediation technique to target the Mordaza River, the Cali 100 landfill, and the Cotoro smelter tributary. These all have heavy metal sources discharging into the river due to paint, electronic, tanneries, and smelting factories, as well as the leachate from the landfill. As indicated by the figure, these are ideal locations to help make the most impact of the spread of pollution due to their higher concentrations. And with success, we can target other sites. So phytoremediation has many applications. The use is best suited for the Almendares River will be for both surface water and soil. To begin, residual filtration uses hydroponically cultivated plants to remediate contaminated surface water through absorption, concentration, and precipitation of pollutants. The giant duckweed was a hydroponic plant chosen to target the Mordaza River and the Cotoro smelter tributary. For one, it's very versatile. Not only does it find success in Cuba's climate, it can survive in a wide range of pHs and temperatures. It also can accumulate a variety of metals, many that are present in the river. In a lab test with a hydraulic residence time of 7 days, our removal rates of these contaminants range between 60 and 94%. The figure on the right further exemplifies the effectiveness of residual filtration with lead contamination in milligrams per liter on the x-axis and the amount of lead in milligrams per kilogram of plant biomass on the y-axis. The trend indicates that with higher contaminants present, the higher the uptake into the plant's biomass. Many of the other metal contaminants listed show similar trends as well. Below is a picture representing a flotation device. This is made of bamboo and used in a successful study of residual filtration in China. In order to keep the giant duckweed in the desired location near the heavy metal sources, a similar device will be used in Cuba. Similar to residual filtration, a suitable plant for Cuba's climate and contaminants present is chosen for soil remediation. The Indian mustard meets these requirements. It will be planted between the river and the landfill in order to create a buffer for leachate and rainwater runoff before they reach the river. An advantage of the Indian mustard is its high biomass. The more biomass a plant can produce, of course, with a higher contaminant uptake. The Indian mustard can also accumulate a variety of heavy metals, even more than the giant duckweed. During a 14-week study from seedling to mature plants, removal rates up to 25% were achieved. The graph below shows an accumulation percentage of chromium, copper, cadmium, and lead, with the soil heavy metal concentration maintained at 200 parts per million in the soil. It's a great example showing the capabilities of Indian mustard accumulating a variety of heavy metals and concentrations higher than the surrounding environment. So much of the data provided prior it comes from laboratory testing. So a great question is, how does it really work in the field? A great example is in Hartford, Connecticut on a brownfield site. A brownfield site is an old industrial commercial site that has some form of contamination present. And in this case, it was in a transitional neighborhood with 2,800 parts per million of lead present on the lot. So they needed an economically viable solution that was also effective. So what they did was they used phytoremediation. They used Indian mustard, Sudan grass, and sunflowers. What resulted was successful phytoremediation of the land and for the community to use. And what I really want to highlight here was that it was in a transitional neighborhood, and it exemplifies the power of phytoremediation under similar economic constraints as Cuba has. In addition to the remediation success, phytoremediation also influenced community involvement such as local middle schools, high schools, and colleges. Involving Havana's citizens would make them more aware of the extent of pollution in the Almendares Basin and show them they can make a difference. This can form important public support for further cleanup action and solutions such as the landfill waterproofing and the wastewater network extensions. So the overall benefits of phytoremediation is it's inexpensive, it's aesthetically appealing, there's a diverse range of species to choose from. If one doesn't work as well, there's many other over 400 species to choose from. And just noted prior, there's community involvement. Reduction in pollutants is proven. It leads to cleaner, clearer waters, less contaminated fish populations, less heavy metals in the environment, and a healthier community. There's potential for farmland restoration, any leaching from the Almendares Basin of the heavy metals, onto the farmland could be taken up through phytoremediation, therefore increasing crop yields and profits. And lastly, there's extraction of accumulated metals. Almost 90% in copper can be seen to be extracted from the plant, and this can be reused and resold. One of the disadvantages of phytoremediation is that contaminant uptake can only be taken from where the roots reach. So this calls for a more extensive and more permanent solutions such as landfill waterproofing and the wastewater networks. And I'll turn it over to Ivan for the landfill waterproofing.
Thank you. So, the Cayecian landfill is a site for the disposal of waste placed right next to the Almendares River. We couldn't find any kind of information about any project for the construction or the operation of the site. But we found a lot of articles criticizing odors and other problems related to the landfill is causing to the population. The runoff from the landfill, leachate, is getting to the river and the aquifer, causing pollution. So we tried to think different alternatives, and we ended with a solution thinking about a low economic impact in the present, but in the future, and to expand the life of this landfill until we can check another better location. So our solution is based in 3 major units. The first is as simple as a soil embankment with a perfect waterproof head style in the interior, ditches and pipes to collect the leachate out of the landfill. Also, this perimeter enclosure will be continued underground with a sand clay screen. And finally, all this water will be collected in a leachate pond. So nowadays, the rainfall will percolate through the waste and divide into 2 fractions. One will follow the topography to the Almendares River, causing turbidity and pollution. And the other percolates to the aquifer, causing the contamination of the aquifer and the upwelling waters. So, in the future, with our solution, this runoff will be caught in the leachate pond where we can make different treatments so it doesn't get harmful for the river. And also, the polluted aquifer will be divided for the aquifer with these screens, assuring the quality of the dwelling waters. Now, Jorge is going to explain how we fix the wastewater network.
Thanks, Ivan. The rest of our proposal is the wastewater network improvements. This is not as innovative as the first one of the phytoremediation, but it's also really necessary. Because there is, in the ventral aquifer, there is a fringe that has even a higher vulnerability due to its consist or a karst geology. What does it mean? That any pollution that is poured here can reach the aquifer even faster than in other places around the basin. So we identified 2 main wastewater networks in this fringe that are Maria del Carmen network and El Cotorro network. Both of them has already the main collectors built, but they lack the connection mainly from the homes to the main collectors. They also have the wastewater treatment plants already built that are marked in the map. So by connecting the homes to the main collectors, we estimated that around almost 40,000 homes will be connected to the wastewater treatment plant. And this will lead to the following benefits. First, there will be a lower amount of contamination in the ventral aquifer, as there will be lower pollution poured into the contributors of the Almendares River or the Almendares River. There will be also lower eutrophication in the Jarcito Rebelde reservoir. That is, there will be less algae in the reservoir, so the quality will be improved. And last, there will be also better environmental condition in the Almendares River banks along its way. Now Ivan will talk about the economic analysis.
Thanks. So to estimate the construction cost of our infrastructure, we made a price database for Cuba based in prices from Spain, USA, and other Caribbean countries we can relate to Cuba. Then we modified this price breakdown, basically increasing the cost of materials and equipment and lowering the cost of the labor to match the Cuban wage. Also, to estimate the cost in time, we apply a financial cost, and after all these costs were made, we increase another 10% to make it profitable to foreign companies to get these infrastructures done. So we end with this kind of graph where we can see more amortization span in years means a higher cost higher total cost for the construction due to the financial amount, but less cost per home and year. This was very important because we need the assistance of the population, because in the model they will be paying this with taxes, so this has to be low as possible. Finally, the total cost of execution will be around $17 million, and with the estimated amortization years around $46 million. The phytoremediation costs weren't estimated the same way because we can see it's a very low cost in front of the other infrastructure, and this means around $5 per home and year during the first 10 years, and around $3.50 the next 20 years, in an amortization span of 10 years for the landfill and 30 years for the wastewater fix. We were satisfied with this number, thinking it's an affordable cost for each habanero to guarantee the safety of the drinking water supply and also restore the degraded environment of the Almendares River. Now, Maut is going to conclude the presentation.
Thank you, Evan. So to conclude, all three of these methods will be needed to significantly reduce the pollution in the Almendares Basin, with phytoremediation being the preliminary, cheaper, easier to set up step, and landfill waterproofing and wastewater network extension to follow. Together, they will improve the overall quality of the Almendares River Basin. There'll be decreased infiltration of pollutants into the ventral aquifer. It will be a low cost per resident, and there will be possible economic returns, and this will lead to a happier, healthier community with the aquifer contributing to the drinking water and their livelihood. They can enjoy a safe and clean environment. And thank you.
I think I had taken the first question. In your presentation, your biggest investment is in the wastewater network, okay? So I would like to, normally the wastewater network, you collect the flow through gravity flow, through a gravity sewer system, and it goes to the pump station. You have the sewer transmission system, and it goes to the wastewater treatment plant. Can you elaborate a little bit more? What are the improvement that you are proposing in that wastewater network?
Yes, according to the information that we have been able to find, there are two wastewater treatment plants that are the Maria del Carmen wastewater treatment plant and the El Pitire wastewater treatment plant. The Maria del Carmen wastewater treatment plant is already built, and according to our estimation, it has enough capacity to gather the extra wastewater that will come from these extra neighborhoods and these new connections, because it's operating under its capacity that what is mainly because of problems of supplies, or there are different problems. And in the case of El Pitire, it also has enough capacity, and the thing that is necessary to fix a pump station, that is the San Pedro pump station, that it's allowed to pump the water from the Almendares Basin to the next basin, that is where the El Pitire wastewater treatment plant. And this is also considered in this fixing of the pump station. It's also considered in the economic analysis.
How about the wastewater treatment plants?
They are working, both of them.
They are working fine? You're not recommending any improvement into the treatment, or?
About the El Pitire wastewater treatment plant, there was not too much information, just the capacity mainly. And about Maria del Carmen, there was a bit more information, and it's possible to accept all the new wastewater network, all the wastewater.
And also, in order to keep it a little cheaper too, we went with this method rather than improving the treatment methods, because treatment methods could be very costly too, to add to a wastewater treatment plant.
Congratulations on a good presentation. I like the fact that you took into account the economics of Cuba and try to bring the cost down as low as possible, and limit your choices on that basis. A question on the phytoremediation. Is that something that the plants that you use get saturated at some point and they need to be replaced? If so, how often does that need to be done, et cetera, and how much of a labor intensive or whatever is it? How much is involved in that process?
Yeah, so basically it just depends on how fast the plant grows, and it's basically pruning the plant to keep it successful. So it's not too labor intensive, but you do need someone there throughout the advantage to Cuba is the growing seasons all year long. It's got a great climate, there's no winter. So you would just need someone there all year to maintain the plants and to keep them pruned in order to keep them growing.
But you don't have to physically replace the plants. It's just a question of trimming them, or?
Yes, yeah.
Okay.
Yeah, you would have to replace them if they were like perennials or if there was a winter season, but there's not in Cuba. So that's a good advantage.
Okay. This is a question out of ignorance as to what's going on in Cuba nowadays, but does the government have any formal controls on all the sources of pollution going into the Untitled River at this point?
I do not believe so. I think there's a lot of discharge straight into the river without any treatment.
And would there be any, in your estimation, since at least you looked at some of these smelters or whatever else it might be out there that causing the pollution, would it be another source of reducing the pollution here at reasonable cost? I don't know what the cost of remediation, well, not a remediation, but prevention are on those sources.
Sorry, I didn't understand the question. Like if there's another prevention method
Is it more economically feasible to treat at the source and by imposing pollution controls on it as opposed to doing this on an after-the-fact basis?
Right.
And
Well, the only possible way is to run it through a wastewater network in order to get to precipitate the heavy metals out of the wastewater. So there isn't too much of a cheaper option. I don't believe so. Yeah.
Can you go back to the economic analysis? So you're saying, what's the currency that you're using here?
We are using dollars, American dollars.
American dollars.
Yes.
And you're saying that you're going to charge Cuban people American dollars.
Yes, this is an estimation. What we were thinking is like in Europe, you pay by taxes to the state collect the state collect the taxes and then pays to the private company that execute the operation. So I don't know if the Cuban government would like to use these amortization rates or pay more or pay less, but this will be something to talk between the government and the companies.
I think that in general it's a good analysis. What I don't like is the final approach of annual cost per home, so per person. First, you cannot compare Spain with Cuba because the model is totally different. Do you know the median salary of a Cuban in dollars?
Yes, we estimated it from different articles. For example, for a worker, it's around $0.50 per hour.
$25 a month.
Yes.
And you want to charge them $5. But anyways, that's just a final approach on charging people that you need to think about where you want to implement. And second, Cubans don't pay taxes.
Of course.
So you're bringing an approach that doesn't work. The only one paying taxes are the foreign companies and the private businesses, like small businesses that Cuban are able to launch. But there is no tax system for every Cuban. So the approach should be like, as a government, what would be the investment, how to work with an investor, a company, to make this happen. But as it works right now, it's for the government, not for the Cuban people. You understand?
Understand. Also, this was made as a kind of comparison to know if this project has a low economic impact or great economic impact. So the rate dollars per home and year, we thought it was interesting to compare to other solutions.
The analysis is great. What I'm telling you is
yes,
I didn't like what you used as
the concept,
the comparison with people, and more as a country or as a city, you need an investment. Don't pass that cost to the people. You understand?
I understand. Thanks.
I like all the work you did. What I read, it's you did a lot of work there. It's very interesting. I have a question regarding the hydroponics. Hydroponics is the way of growing plants using water with a special treatment that has all the nutrients there. However, when you put it in a river, heavy metals will just sink. So unfortunately, I mean, the solution would be not to pollute the river to begin with. But I'm not so sure that putting plants will take care of more than surface water. And when you're talking about heavy metals dumped by industrial complexes, those will sink almost immediately. So by the time that it gets there, I'm not so sure that that would be a good solution. I mean, it's nice, but I don't know if it'd be practical because of the heaviness of the metals.
Yeah, so giant duckweed does have a fairly fast equilibrium time where it does take up, and is about 20 minutes, so you would hope that effluent coming out will churn the water a bit, and it'll make a difference, at least a little bit of a difference, taking some of the heavy metals out of the water.
But then you're proposing to actually put all the plants adjacent to where it's dumped. You know, it's like having a nurse next to somebody being killed.
Yeah, and I mean, another option, it'll be a little more expensive to set up, but you could set up a greenhouse and run the effluent through the greenhouse and touching all the roots and then out into the river. It'd be a slightly more expensive.
The solution is to eliminate the pollution. That's the effluent, because there's no way. What you're proposing is something that will be after eliminating that. How do we clean it? How do we clean the river? Which is very important. I mean, it's not a bad solution, but I don't think it would be practical because of the depth, and I only will take care of surface water. In most of hydroponic cultivation that it takes place in the world, the roots are actually passed through a right amount of water with the nutrients. So that's all they do. Below that, there's no absorption. The metals will not rise, and the plants do not have the suction capacity to actually lift the metals from the bottom of the river. So that is but a lot of work you guys did. Thank you.
Just one more. What is the connection between the University of Illinois and the Technical Institute of Madrid? Okay. Okay.
He's from Spain. He grew up in Spain.
Okay.
Yeah.
Okay. All right. This question, and it is to the two Spaniards, does have nothing to do with the presentation, and I already scored. So, which team do you support, Atletico or Real?
You better answer right.
Or you support another team?
I support Zaragoza because I'm from Zaragoza.
You support?
Zaragoza.
Zaragoza.
Second division. And I support Real Sporting because I'm from Asturias.
I'm glad to hear that. I'm glad to hear that because I support Barca. I hate Real Madrid. Okay.
It was a good thing that the report was already scored.
Believe me, it was.
Thank you. Thank you to the Illinois team. Up next, we have the Florida International University team. They will be presenting on UV water treatment alternative, and they'll be working on specifically on the town of Herradura.
Well, first, we'd like to thank you guys for allowing us to present here today. We are the FIU chapter for CAACE. My name is Eric Castillo, and I'm an undergraduate for civil engineering.
My name is Lázaro Rosset. I grew up in Cuba. I'm studying here too. I went to the Cuba in Cuba, and now I'm going to the Florida International University.
My name is Maria Gonzalez, and I'm pursuing a civil engineering major.
My name is Gloria Suarez. I'm an FIU former student, and I grew up in Cuba as well.
So today we're presenting the development of a UV disinfection system in Herradura, Piñal del Rio for Cuba's infrastructure for a water treatment plant. Okay, our vision here is to provide innovative solutions towards the development of Cuba's infrastructure and to improve the quality of lives for future generations. Here's a map so that you can see Herradura to the west of Cuba. And here's a closer image to see how developed the town is at the moment. So right now, the area covers about 9,000 square yards. And when we were deciding what kind of water treatment system we're gonna do, we wanted a design life of 20 years. And we noticed the current population right now was about 10,000 people. When we were researching the population growth rate, we noticed that it was actually declining through the past years. And we really didn't know what to make of it at the time, but we decided to go with a linear growth formula, and after 20 years, it remained the same more or less. We assumed 100 gallons per capita per day per person. This is based on a US standard. This is a little too high for the actual water usage that Cubans use. Through some sources, we noticed that it was actually 80 to 120 liters per day per person, which is approximately 40 gallons per person a day. And so our water treatment system, we have it at 1 million gallons per day, which is 694 gallons per minute. Okay. So the project consists of the design of an ultraviolet water treatment system in Herradura for a population of 10,000 inhabitants. And the 1 million gallons per day is a little high, but it can account for any estimations that we can account for with the current population growth rate. We're assuming that this is for a free market economy. So the current issues that Cuba is facing at the moment, the drinking water that they have is contaminated with cryptosporidium and giardia, which is not a bacteria, it's actually a protozoa. And while we were thinking that chlorine disinfection can treat this, chlorine cannot treat protozoa, it can only treat bacteria. So that's why we decided to go with a UV disinfection system. Another problem is that they're undergoing water scarcity at the moment. And we are trying to find an environmental friendly alternative, clean the water without residuals that may affect the environment. And with chlorine, when you inject chlorine into the water, chloramine is a residual that is produced that it's a carcinogen, and it affects the health of the individual. And now I will pass it on to Nazar.
Okay. Thank you. Go ahead. So we are using the UV lamp energy to treat the water in order to deactivate the DNA on the microorganism, especially in Giardia and Cryptosporidium. The UV energy comes from the wavelength that is in between the X-rays and the visible light, and the germeric range, that is the range that actually kills and destroys the DNA of the microorganism, is in between 200 nanometers and 300 nanometers. Especially in this case, the apparatus we are using has a wavelength of 254 nanometers. Go ahead. Okay, this is the way it works. The UV lamp, the energy that it emits, destroys the DNA, what is like a database for all the information that all living organisms have. If you destroy the database, the DNA, the organism will not be able to reproduce and will be inactive. One of the biggest benefits of this is that this doesn't require a lot of time in order to treat the water. Actually, in our case, we only need less than 10 seconds to treat the water. It has a low capital cost compared with other alternatives that have been proved to be ineffective, killing giardias. Operates at the same pressure that the system does, so you don't have even to increase the pressure in order to make the UV lamps work, and does not involve any chemical. That's very important because it's been found that the chemicals have a very negative effect on people's health, and we want to move to a new alternative. And the UV lamp is the only alternative that has been proven to kill the giardia, because the giardia enquist, and when it enquists, it receives all the chemical action, but it's not able to resist the energy coming from the wavelength. So that's why we decided to use the UV lamp. Good. We wanted to see the effect of both alternatives on the environment. And when we decided to go ahead and do a life cycle analysis, we determined that the most critical phases of our product were the pre-manufacture and the manufacture of the UV lamp itself, because you require a lot of energy, but once you have the product, you can use it without affecting the water or creating pollution or solid residuals on the water. That's pretty good compared with the chlorine alternative. where you have solid waste and you have effect on the water, and at the end you're not killing the giardia. Okay? So when we were designing the project, the system, the biggest challenge we faced was that the UV lamp doesn't have a residual. So after the water leaves the system, it can be contaminated again. So we decided to move from a centralized system to a decentralized system where we place the UV lamps at the end of the distribution. In Cuba, if you go to a rural town, they have like, in the US they also have that, they have like water tank towers where the water goes there and then it's distributed by gravity to the town. So we're gonna place the UV lamp at the end of the water tower tanks. Okay. Now it's gonna be Gloria.
The components of the ultraviolet system, disinfection system that we're going to use are the UV lamps, the transparent cord sleeve that are needed to protect the UV lamps from the water that is going to be disinfected, the structure that is going to hold the system in place. We're also going to have the power supply needed for cleaning the cleaning system and the UV lamps, the online ultraviolet sensors, and the cleaning system that is required to maintain the transparencies of the cord sleeve. In this image, we are showing the basic functioning of the UV system that we're gonna be implementing in Herradura. First, the water is gonna go through a sediment pre-filter, and then the water is gonna enter the ultraviolet chambers, flowing through an annular space between the sleeve and the outside wall of the chamber. Then inside there, the water is going to be exposed to the ultraviolet lights, and the microorganisms are going to be inactivated, and the water is going to be purified and disinfected. There are two parameters that we are going to consider in the design and control of this project. One of them is going to be the ultraviolet dose, and the other one is going to be the quality of the water. The ultraviolet dose depends on the intensity, the ultraviolet intensity, and the time of exposure. The ultraviolet dose is going to be determined exposing a well-mixed water example to in a small batch reactor to a collimate beam, to a collimate ultraviolet beam, and we are going to, after that, for a certain period of time, right? And after that, we're gonna observe the behavior of the microorganisms. And the other parameter that we're going to have to consider, that we need to consider, is the water quality. And the water quality is going to be controlled through the transmittance, which reflects the amount of ultraviolet radiation through the substance in a certain at a certain wavelength. The absorbance is going to be measured after the water goes through the pre-filter, and then we're going to calculate and control the transmittance of the water using the formula. And now my colleague Maria is going to continue the presentation with cost estimation.
The cost-benefit analysis, according to Aurora 2001, the operating and maintenance cost for a 1 million gallons per day facility, it's around $22,000. And the operating and maintenance cost for 100 million gallons per day, it's around $26,500. We based our calculations on US dollar, and we based it out on a free economy market for Cuba in the future. and we use the United States as a reference. This is the water quality assumptions for the median water facility. That's what we're gonna focus on. On this graph, we found that the design flow for a 1 million gallon per day facility, the cost will be around $110,000. And on the other graph, as you can see, the percentage of total capital cost for a medium facility, the biggest percentage of the cost, it's on the UV equipment. The rest is not very expensive as compared to the UV equipment. Now for the operating and maintenance cost breakdown for a median, staying with a median quality facility for 11 million gallons per day, the operating cost lies between in between $23,000. Now we have another reference for the cost for median quality water. And now for this, the capital cost will be between 1.1 and 1.4 million, and the operating and maintenance cost will be between $19,000 and $39,000. For future considerations, the first consideration that we have is determine the specific areas where the reactor is going to be placed in Herradura, Cuba. And the second one is design the exact capacity of the sediment per filter and UV chambers for the accessibility of the water to the population of Herradura. Thank you very much, and now we're open to questions.
Okay, would you mind putting the slide the beginning of the economic analysis, please? Yeah, well, that'll be fine. None of these parameters will be the turbidity, alkalinity, hardness are affected by the UV light. Actually, what you're comparing is UV versus chlorine, that's it. The rest of the treatment plant has to be there, that you have to remove all the solids, everything. So the difference is whether the economic analysis should be whether the cost of adding chlorine or adding UV or having both. Because with UV you don't have a residual effect that you will have with chlorine. With chlorine you have also residual effects beyond that, like the contamination or things like that. So that's a true analysis. The rest of the analysis, I don't find it relevant, because the plant still will have to be built, you need to clean everything. The question is also whether, you mentioned that you want to put this UV at the end of the process, not in a central, but this is pretty much in a central area, because otherwise you want to put it in a house. Like in my house, I have a filter, and the filter includes some type of carbon activated things plus UV. But I live in Coral Gables. This is Cuba. They won't have electricity. Anyways, I find this more appropriate to other places, and I think that your economic analysis is missing. It's just only chlorine versus UV, unless I'm missing something, please.
Okay, yes, let me go back to the Herradura map, where it's at the beginning of the presentation. Okay, as I was saying, we determined to place the UV lamp at the end of the distribution line. So we are planning to have like 4 or 5 tower tanks on the small neighborhoods, so we can place the UV lamp at the end, right away where we are distributing the water into the houses. Small houses like small neighborhoods compared here with condominiums or something like that. That's the main idea. That's the way we think we can reduce the risk of contaminating the water after the water leaves the UV lamp.
But I don't see the cost of the towers. You see, if you're gonna do that, and again, it's just it's chlorine versus UV. You need to add the cost of the towers, because you will require an additional treatment at the end, closer to the person who uses the water.
Thank you.
So you said you're going to have 5 units. That's what you're saying?
Yes, depending, we have to do future calculation, but depending on the growth of the population, because this project is to be implemented in the future, and we don't know actually how the population is going to behave in the future and how the economy is going to be. We are planning to establish the VLANs at the end, maybe 4 or 5, depending on the population and the distribution of the population in the area.
And then on the economic analysis, you're using prices from 2001?
Yes, they're using prices from 2001.
Do you think the price from 2001 will be the same price that 2019?
As I was saying, this is going to be implemented in the future. Actually, we don't know this is an assumption. This is going to be implemented when Cuba reaches the free market and when Cuba has the possibility to pay for it, or maybe has sponsors.
But more than that, do you think the price from 2019 will be the same price as 2001?
It's going to decrease probably, depending on how developed the technology is going to be.
Okay. In your written report, I think you made an assumption of 10,000 population here.
Yes.
And then you said that the increase would be from 10,000 to 20,000 or not. I think you mentioned that. And you have made that adjustment now. But I think in the written report, you made it from 10 to 20, I think. And then I don't remember the period of time, but I think it was 10 years or 20 years?
20 years.
20 years. Well, at the beginning of the revolution, there was 6 million population in Cuba. Now there is 11. So in 60 years, the population even hasn't duplicated. Well, the other million is probably here in Miami. But going to the system that you're proposing, I think it's a kind of sophisticated system for this. And I don't know the way to operate also. You need to train people and all of that, and probably the initial cost of you said that it's a low capital cost. When you mentioned in your presentation low capital cost, what you were referring to? To the equipment?
To the equipment. Also, the system has been implemented in Africa and is being successful. So probably Cuba has a higher level of education than Africa.
Okay. All right. That answers my question.
Since you said you were going to put the UV lights at the end of the process, what is at the beginning of the process? What's the current water treatment in Herradura at this point?
Okay. The water is coming from groundwater and it's going to be
from an aquifer?
Aquifer, yeah.
Okay. And
the quality of the water in rural area in Cuba is pretty good. It hasn't been contaminated with chemicals neither, because the rural activity in Cuba is pretty basic, so it doesn't have that many contaminants like in many other places. So we are gonna pump the water and we are gonna treat it how Gloria was saying, and then we're gonna put it into a water tank, and we're gonna treat it with a UV lamp to kill the giardia. That is what is affecting the population of Cuba.
Okay, and since the electrical system in Cuba is so unreliable, are you relying on storage of the tanks to sustain the system? And is there some kind of system that would say, no, you can't send the water out for distribution because the electrical hasn't worked in 2 days?
Okay, so yeah, hopefully that won't happen in the future of Cuba, and we can support the system with solar panels, and we have the water storage in the tanks.
Who came from Herradura?
No, none of us came from Herradura.
Okay.
Our previous team leader came.
Yeah, he came from
the previous team leader. So I just want to say that this is a real project, and there is a real problem, and giardia is very common in Cuba, and being, I came from there. I lived with giardia all of my life, so I can relate to that. And I think that you have a real project, you have a real solution. You need to believe more in your product. You don't need to think about the future of Cuba. You should think about how to implement it now, like the previous teams that were presenting. How can we implement now? How can we bring a solution that can fix the problem? Not thinking about the future, thinking about right now. And I think that, as you mentioned, it was implemented in Africa. Why not implement it in Cuba right now?
Honestly?
So it's just a comment that you have a great project. if you believe in it, you can make it happen.
Honestly, I don't think that it can be implemented in Cuba because the Cuban government wouldn't allow it. Like a few months ago, we had hurricane in Cuba, and Cuba doesn't want the Cuban exile community to help the Cuban people. So with the current government, it won't be possible to implement any project in Cuba right now, honestly.
I think that's not the right approach, and I think that yes, they're willing to accept support if you go through the proper channels, and that's different. And what you're proposing is going to help not only people from Herradura. If it's a cost-effective solution, it can help everyone in multiple small towns in Cuba. So I think that you can believe in your product and you can implement it.
Okay, thank you.
Okay, thank you. Okay, we have one last team before lunchtime, and I'm not going to say best for last, but it's the University of Florida team. Go Gators. So Luis Gonzalez today, he's going to be presenting on material recycling in Central Havana, and his faculty advisors, Dr. Sophie and industry mentor Eric Bolnes, have provided a lot of support to Luis, and we'll let him get started. After this presentation, we're going to take a 1-hour break and go out for lunch. There's going to be lunch downstairs, and then we're going to resume the presentations of the awards at 1 o'clock. So, Luis?
Thank you. Hi, good morning, everyone. My name is Luis Gonzalez. I'm working in my Bachelor in Civil Engineering at the University of Florida. Today, I'm here presenting my ideas about the material recycling facility in Havana, Cuba. I wanted to show you a few pictures so you can have a better idea of what is the problem and where are we going with this project. These are common pictures of Havana, not only of Havana, of every place in the country right now. Every corner is full of trash because there is like a huge problem with solid waste management. As you can see, there is a mix of trash over there. There are two most important types of trash in the pictures. One of them is related to household, like plastic, paper, and glass, and the other one is coming from the demolition, collapse, and construction of new buildings or even houses that are small repairs. What is the problem? Both of them are mixed, both of them are on the streets, and it's really, really difficult, almost impossible, to collect like that, like a mix, and then to process it. There is no way to process that mix. So we are going to attack the problem, we are going to provide a solution and a few ideas on how to make the problem or how to solve the problem. Okay, as a Cuban, I know that this is a huge problem, but I wanted to make sure that I was on the right track. Because of that, I did a poll with the help of my friend, my colleagues, I did a poll with the help of many, many people. I got about 507 answers. I asked my fellow Cuban, how bad do you consider is the situation with solid waste management in Cuba as right now? Almost all of them consider that there is a significant or critical problem with solid waste management in Cuba. The results are there, as you can see: Havana, Villa Clara, Camagüey, Las Tunas, Holguín, Santiago de Cuba. Some are the worst places in Cuba right now. There is a common denominator: population. Those places are like the most populated cities in Cuba. Because of that, it was easy for me to understand, okay, this is a common denominator. I want to point out that one of the causes or why this is happening is because of the lack of recycling facilities and the improper disposal system. As I was saying, it's impossible to remove or to separate that mix that is on every corner of the country. I wanted to tell you about this, keep that in mind. Right now, this is the only data that I was able to get from a confiable or from like a really good source. About 1,000 cubic meters of construction and demolition materials are being produced in Havana, mainly from the construction of new hotels and also for the collapse of all structures. Where I'm going? Okay, I want to provide with a few ideas about the design of a full system. I don't want you to focus only on engineering idea. I want you to see this project as a factor of change for society. I'm focusing on the three most important aspects, in my opinion: the environmental, the economic, and the social aspects of the project. This is so you can have a better idea of the main points. What are the points that I'm attacking today? I want to explain you what is a material recycling facility, because the naming is kind of what is. I wanted to talk about the economic analysis, the location, how it's going to be the location. I want to cover like all the details next to the construction of a material recycling facility and the functioning of the facility. Okay, what is a material recycling facility? Is kind of simple. It's a place where materials are separated, are processed, and then stored for future use. The most important goals: maximize the quality and the quantity of the recycles, because at the end we are going to be reusing all the materials getting out of the facility. Okay, before the presentation I made a decision. I wanted to explain like in deep the technical process, or I wanted to attack the problem in general, and I decided that I want to explain the technical process, but I want to provide a full idea of how to solve the problem. Because of that, I'm going kind of not very deep on the technical process, but I want you to have an idea of how it's going to be inside and how it's going to be the process. As you can see right there, the step number one is going to be the collection process. The collection for me is super important because we have a great idea, but if we don't pick up the trash from the streets, there is no way that we're going to solve the problem. The collection is super important. I'm going to explain a little bit more about the collection. Then, with trucks, we're going to deliver the materials to the material recycling facility. We're going to put the materials on the tipping floor, and then with the front loader, we're going to take the materials and put it inside a shredder. We're going to after that, we're going to have the system like here, and then here under the system, we're going to have a conveyor belt. The conveyor belt is kind of the most important I think the conveyor belt is like the soul of this system, because the conveyor belt is going to transport all the materials along all the way in the facility. We're going to have a conveyor belt, all the materials are going to be there, and then the conveyor belt this is the conveyor belt, it's coming this way, and here we're going to have a rotatory magnetic separation system. It's going to pick up all the ferrous materials in that mix. So it's going to pick the material, it's going to be rotatory, and it's going to reach this point, and here it's going to drop them in a different conveyor line that is like an auxiliary parallel to the main line. In that way, we don't have ferrous material for the next level. So the conveyor belt continues movement, and then we have a suction separation system. It's the same, main conveyor belt, non-ferrous materials there. The suction system is going to take light materials, plastic bags, paper, styrofoam, coming from construction mainly, remember? It's going to take them, it's going to move them, and it's going to drop them in a different system. Another conveyor lane, smaller, and that system is going to have an optic sorter. Optic sorter is a system used in material recycling facilities here in every part of the world, not for construction, but for common plastic and paper. It's super precise. It's going to take only the paper. It's going to take the paper away for further processing. Then we continue with the main line. Right now, we don't have ferrous materials. We don't have paper or lightweights. We continue, and we are going to do the wood separation. The wood separation is kind of simple, but I like it. We continue on the line, and suddenly we have an angle going down. This angle is going to be an area full of water, and then all the materials are coming down, and because of the buoyancy forces, the wood particles are coming up to the surface. We're going to be able to remove the wood, and then it's going to go up again. The conveyor lane is going to continue with the rest of the materials. At that point, we don't have ferrous, we don't have small particles, and we don't have wood. What we have, non-ferrous materials at that point, copper, aluminum, and also a mix of rock and concrete. Manual sorter is almost the final step. There, someone is gonna picking up small pieces of aluminum, copper, and finally we are gonna get the rock and concrete mix to use based on what on the needs at that point. Okay, I wanted to mention about collection, because I think collection is too important. The equipment, we need the right equipment, many trucks, I try to explain that in my paper. The manpower is also important. People need to have like preparation, be aware of the importance of the work that they are doing. And social programs. I don't know how much importance has social program. For me, has all the importance that this, I mean, we can have a great idea, but if people doesn't cooperate or doesn't help or doesn't get in the project, we are doing nothing. Social programs, there is this theory, I like it. Someone told me about it, and I think it's very appropriate to this situation. When you see a broken window, or a few broken windows, you are most, like, you get excited, or you are most prompt, or you can get a baseball ball and break another window, and that is going to be fine, because the environment is like that. There are too many problems, another one is not going to make a huge difference. But if you see a place clean and perfectly organized, probably you're going to behave, and you are going to try to keep that place like that. So I have in mind many ideas to get, to get those social programs work. I don't want to go too strict with fines and all of that, but I think could be also usable. But that's what I'm thinking right now. Dumpster online reservation, a few ideas to pick up the trash from the street, and the delivery. The delivery is going to be mainly on trucks, so you can have an idea. That is going to be the delivery. Trucks are coming, leaving the mix. That is going to be the mix, mostly wood, concrete, small particles of aluminum, styrofoam. So these are a few pictures so you can have visualized what I was saying, because it's kind of difficult to understand the conveyor belt going all the way. That is a similar industrial cheddar. You can see it's coming like this. Then you have a conveyor belt that's all the way around the system, and that one over there is kind of a similar system that the one that I have in mind is rotating. Conveyor belt is moving up like this, straight line, and that one is moving like this when getting the ferrous materials and moving to a different lane. That's my idea. Okay, the facility design. I want to have a facility ready to increase capacity at any point, because I'm pretty sure capacity is going to increase and demand of this service is going to be high. I want to use the least number of columns inside. I want a system like clear and open, so there are no accidents. People can move freely with the trucks, with the loader. Employees, I want to have like areas for employees. The internal design, I want the internal design to be enough to accumulate materials for 7 continuous days. For example, if we have a problem with the metal system, I don't want the clients to have, I don't want to stop accepting material to the facility because of a problem that we have. If we have capacity to accept material for 7 continuous days, we are not affecting the production, or we are not affecting our clients. And I'm pretty sure 7 days is enough time to fix any problem inside the facility. Storage. I put great importance in storage because we are doing a business at the recycling facility, and to make the economic analysis successful, we need like a great system, a perfect system. I want to have a huge storage because materials, the market is kind of changing, and every day you can see a different price for a material. Not drastically different, but you can see a different price. I want to sell materials not before or after, but I want to sell them at the perfect time, at the perfect point to make the most profit and make the facility like successful. Capacity. Capacity is about 7 times the actual capacity of the actual production. Why is too big? Okay, I think that the economy and infrastructure in Cuba right now is in coma. And I'm pretty sure that when we start building, when we start rebuilding the country, it's going to be huge. It's going to be a different, like a strong difference. I'm super confident about that. And that is the maximum production. I'm not saying that from one day to the other it's going to be an increase of 7 times what is going on right now. The location, the potential location for this idea is near the University of Antonio Echeverria, the Cujay. That area, there are a few landfills in that area, and I think it's like an industrial area. There are not many neighborhoods around. There are, but there was a central in the area, and I think it's a good potential location. My idea is, I decided to go with this location because there are not information about how much construction waste is being produced in Santiago de Cuba or in Ciego de Ávila. So I decided to go with this one, that Havana is the only place with real numbers. The economic analysis. Okay, to do the economic analysis, it was for me like super difficult because all the details that you might have an idea or the economy of Cuba. So based on my experience, the experience of different Cuban engineers and the experience of American engineers, I decided to do like a factor. I decided to talk to them, okay, how much would be this design facility here in the United States? How much would be that in Panama or in Dominican Republic? I used those 3 places of comparison. And then, based on the expected median salary, I did a design factor to accomplish for that, to make that difference. And I think maybe it's not perfect, but I mean, there is no way to make exact, no one, even a great economist could do like a precise assumption. I think the total cost for the facility, including engineering, design, equipment, capital costs, are going to be about 20 million. That includes everything, trainings, everything that we need for the facility, permits, design, the annual payments. The annual payments, about a period of 18 years at the 12% compound interest rate are going to be about 2.7 million per year. And the operation and maintenance costs, about 1 million, including salaries, including double salary in December for the employees, including all the expenses that we may have. Based on that, I'm thinking that the expected annual revenue is going to be 5.3 million. We are saying that we are going to have a profit of 1.6, about 1.6. Based on the future, we need to make a decision if the facility is going to be public or private. I'm open and able to collaborate with the actual government to provide my ideas to implement this facility. I don't think they are going to accept it, but I'm able to do it. I know that I'm over the time, but I want you to know about this because this is the slide that I like the most. The social benefits of the project. Okay, I'm proposing with this project to open 28 working positions, including labor, including truck drivers, manager, everyone that is going to be involved. 8 hours working shift, Monday to Friday. I don't want to do it on weekends. It could be necessary, maybe. The average salary that I include in my economic analysis is $500 per month to the workers. Is highest than the average salary on Latin America right now, and is about 30 times the average salary that workers are receiving in Cuba. Accounting for that, the economic analysis is still perfect, clear light. So I think that it could be even higher than that. Another benefit that I want to include to make the community get involved with the project, I want to do tours for a student and visitor. Safety, glasses, everything. But I think that the social benefits of the project are going to be amazing. We are not only impacting 28 working positions, we are impacting about 100, maybe 200 people, including the family of the workers. Okay, I'm a little bit over time. I have other few details, but I want to stop. Okay, these are, a few environmental benefits of the project. I have a lot to say for this, so I don't want to take more time. And these are my final ideas. My final ideas. Okay, Cuba's future is uncertain, that the necessity of a system for the people is a fact. And another idea that I want to say, that which is going to be the scope of my next project next year, is that there is no way that we can do any project, mine or any of the project here, because we need to rebuild the highways and the streets of the country. So that is going to be the scope of my next project. And this, for me, I'm like very passionate about this. This, for me, are more than an idea. This, for me, is going to be a reality. I'm confident, sure, that I'm going to make it happen.
There you go.
Right. Thank you.
Oh, yeah, you're very optimistic, but it's a good thing. That's a good thing. It's a good thing.
I am.
No, I salute you first for wearing a guayabera.
Thank you.
Well, it reminds me that the summer is coming and I have a few in my closet. I never wear them. But anyway, comments about your project. I think you were tackling a necessity in Cuba. There's no question, and especially in Havana. There's no question about that. As part of your optimism, I don't have too many relatives living in Cuba, but believe me, if they know about the salary you're going to be paying, maybe you're going to have doctors working for you in that place, for sure. No, I think you did something that is really important, and I want you to just elaborate about that a little bit. You said that you made a survey. At the beginning of your presentation, you made a survey about what one of the most critical issues there Cuban population is facing nowadays. And I wondered, how do you accomplish that? I mean, if you elaborate a little bit more on that.
Yes. Yes. I did a survey with 2 main questions because I know this problem is so bad. So one question was, I didn't want to be biased, so I didn't put how bad is the problem. So I put, how do you consider is this situation in Cuba? So many people fill out the survey. I didn't the survey to be biased, so I tried to get my friends from Cuba because I finished high school there, so I have many friends. I tried to get as many people living in Cuba involved with the survey. It was easy because it was only a link. I didn't use it Qualtrics. It's a system, it's kind of expensive, but I have access to it by my student membership at the University of Florida, so I used that system. I did the question, I put it, and then I share it with my friends.
Do you remember exactly the questions that were asked?
Yes, 2 questions.
Okay, what was that?
How about, I have one at the beginning of the project, I can say, how do you consider is the situation in relation to solid waste management in Cuba right now? And the second question is, where are you from? In order to make the map with the numbers. So if people from Havana think that the situation is great, I wanted to put, okay, Havana is great. I'm from Ciudad de Ávila. I know that it's kind of normal. Maybe when you get a different view, if I go there now, I think, okay, the situation is critical, it's a disaster. But for people living there, it's normal because maybe they go to Las Tunas and they see a lot of trash on the corners. And so I wanted to have the people living the situation right now, I want to have their input in my project. So that's what it wasn't easy. It took time because, I mean, to get connection to the internet is a problem, but my friends, and usually young people are like, they understand better the internet, and it was, I mean, it was good in that sense. Yeah.
So Luis, what are you studying?
Civil engineering.
Civil engineering, okay. Can you go back to the first slide where you have the pictures?
Yes.
So, good. Now, I want you to be honest. Do you think those pictures are definitely real?
Yeah.
But do you think the problem of those pictures is because there is no factory to process everything that you see in the pictures?
Because of that, I tried to explain about the broken window theory. The problem is a mix between the society doesn't care about helping at this point, and because there is not a place to process that mixtures, including the lack of equipment and recycling facilities. It's a mix, not only because there are not the facility to process the mix, because there is not the full program to attack this problem.
So I think the facility exists, not the type of facility that you say and the salaries that you're mentioning, but I think that exists. I think the problem is with transportation. The reason for those pictures, the reason for the garbage to be there for weeks is because there is no transportation. Not necessarily because there is no factory doing recycling, because actually it's not only about recycling, it's just about collecting the garbage. That's a real problem. And that's why you see a lot of garbage everywhere in Cuba. So I think that you're trying to bring a, yeah, it's a nice project, but I'm missing like the engineering component, if it's supply management, if it's transportation, but I'm missing the engineering component of more than a real problem. Is that for you as an engineer, is that what exactly is that the engineering component that is going to fix the problem? More than just saying, yeah, let's build a factory. Yeah.
Based on my knowledge, and I mean, I may be wrong about it, but based on my knowledge, the only facility processing this type of material is in San Miguel de Padrón, in an area called the Diezmero, and they are processing the materials, only crushed concrete. The situation is so bad that they are using that crushed concrete as a cement. They are mixing with cement and then they are building. Not building foundations, but they are building like laying bricks and doing that stuff. On my knowledge, and from former professor of the CUHAI, from where I got these numbers, they don't know about the facility doing this type of process. In my province, I'm not from Havana, it doesn't exist.
Well, the second piece is to process what you get, but that's not going to fix the problem of garbage on the streets.
Yeah, exactly. That's why I'm trying to make a compound, implementing the ideas to get the population in that and also the collection. I agree with your point, I agree, but I don't think it's only transportation. Right now, Cuba got 92 trucks from Japan, and they are not going to solve the problem. We can introduce 1,000 trucks, and the problem is not going to be solved because of the lack of a structure to make them work. Because people driving the truck driver, they don't care about that. And the trucks, the streets are so bad that the trucks are going to be destroyed in 2-3 years. So, I mean, I respect your point, but I don't think it's a transportation problem.
I don't know if I have a question. I have a couple of comments, and I think it's not only for you, for all the participants, for all the engineers. We sometimes focus on the problem as a technical problem, and I think what your approach is, there's a social impact to whatever we do, whether there's a road and whether the road is made out of asphalt or cobblestones. We impact everything. We impact society. And I happen to agree with you that the broken window theory is absolutely correct. When you go to a neighborhood, you don't care. People throw away. Even people, highly educated people, that they won't do it somewhere else, they'll do it there. So your approach of looking at the technical plus the social impact, in addition to the economic impact, we engineers, we need to look at all the aspects, because this is very important. Whatever we do in life, in society, it will impact not only us, but future generations. Those who built whatever they built 200 years ago, we don't know the names, but they impact us today. So I congratulate you on that. But another comment is, have you thought of, even though it may not be feasible today with the current government, but the byproducts of this plant, like, for example, the crushed concrete, this could be used to do cobblestones or other things that will actually be a residual income for the facility, and they will be used even in a system, a feudal system that they have in Cuba. They can use those things for recycling for other uses. So that would be an additional income. Yeah. And one more thing. I work for a company that the president of the company agreed to pay the highest salaries possible. I was paid a lot of money for my job, and I asked him, why do you pay like twice as much as you pay any other company? I was so happy. I said, because I will squeeze you out 3 times as much. If you do that with your employees, whatever it is, you can always get the very best, and it doesn't matter whether the job is a menial job like sorting things or education. You need to pay the people the very best. I think you get a best example.
I was planning to make a point about the reuse of the material on the environmental side, but I didn't have time.
Luis, I commend you on your enthusiasm. I want to ask a couple of questions because I'm not understanding the economics, and I don't want to get into the specifics of the dollar analysis, if you will, but you said that you were going to have an internet-based or an online-based system of reservations for people for clients, but I'm not sure who the clients are. And are these people that are renovating properties, or if I live on 23rd Street in Havana, and I see a lot of debris, I just say, hey, let me go, Luis, and come and bring me one of those trash bins and come fill it up. Well, if there's no charge to me, I don't care. I'm just going to call. Come pick it up. Yeah. So what is it? Are you collecting dollars up front? I never saw anything there that said, I'm collecting this much from the people when they make the reservation. And also with the byproducts later, as to you have a system of waiting for the right time to sell a product, if you will. I don't know that you can rely on a real-time market or you might have waste or sitting on the property for quite a bit. So could you comment on both
Yes.
of those sides, at the beginning and at the end?
Yep.
Thank you.
Going from the end then to the beginning. My plan, or again, how I have organized it in my brain is the storage, have the products there at least from 1 to 3 weeks. That would be the maximum time. And based on that analysis, how the market is going to fluctuate during that time and try to sell at the perfect point. Going to the other point, that was another point that was on my desk thinking about for a few hours. I want to make this accessible from the huge construction. Right now, they are only building hotels, but I don't think that I can, me personally, that I can do this facility right now. If we were to do it right now, the main customer would be the hotels going on, building in Cuba right now, but I also want to make it accessible for people doing like small repairs. If we're doing a small repair, there is no way that as a homeowner, you have the knowledge or the ability to do a small repair without a permit, without the full drawing of or plan of what you plan to do. So I think that people need to request permits to do remodelation or to do any repair, and based on that, they can request also like a small, depending on how much trash, debris they are planning to collect. Based on that size, volume, they can request a smaller dumpster, or if it's a huge project like a demolition of a house, they can get like a full dumpster. That's kind of my idea at this point.
And what would you be charging these people when they make the reservation?
I'm planning to introduce the program at no charge for the people collecting the material, based all the profit on selling the residuals, because the program is proved to be 98% like perfect here in the United States. So I'm hoping to get I'm sure I can get about the 95%, like recycle 95% of the material coming in, and from the sale of those material, the profit on my economic analysis is based on that. Because the culture in Cuba, if I charge a person to do that, they are going to go with the truck at night and they are going to deposit the trash on a landfill.
I understand.
My program is kind of based on that. I want to introduce slowly, and then after that we can think about small fees. I mean, for a hotel, they are working with the government, not with this one, with the future government, and it's going to be different. For a hotel, you need to have all these legal requirements, and it's easier to charge them. But the person doing a small repair, they are going to go at night and pull the trash in the next corner or everywhere. So
no, I understand your point, but
yep.
You know, like I said, you might be overwhelmed by requests for people to come pick up the stuff if you don't charge up front.
Yeah.
And second, with respect to selling at the perfect time, the only way you know if you sold the perfect time is in hindsight. So timing the market is difficult. Otherwise, we'd all be rich in the stock market.
All right. Thank you so much.
Thank you.
You're welcome.
Let's give all 6 teams a big round of applause. It takes a lot of courage and a lot of preparation for them to come up here and give us their presentation and then be grilled by these judges, which we really appreciate their efforts and putting some of these projects in very relevant content. So we're going to take an hour break. We're going to get some lunch, and we are going to be back here for 1:15. And then we're going to ask the judges to give us their thoughts on the teams, and we're going to start awarding the prizes. So stick on, and we are going to be doing a photo downstairs. So maybe before we grab lunch, we can go out to the yard and take a whole group picture. So let's do that first. Okay. We are going to get back and get started from lunch. We had some time the judges had some time to deliberate in terms of the competition and the presentations. They talked a lot about the various students and the various projects. And so we're excited to go through the award ceremony this afternoon. Before we do get started, I do want to welcome Dr. Elena Solo Gabriel up here. She has a couple of things that she does want to discuss with respect to ASCII in terms of the secondary organization. Yes, I have a slide that's coming up.
Thank you.
Okay. I just want to let all the participants know that there's a sister organization to the Association of Cuban-American Engineers and Cuban-American Association of Civil Engineers, which is the Association for the Study of the Cuban Economy. And every year the association has a yearly conference where they have a student competition, plus they have a lot of academic type presentations. They're very open to anything related. It doesn't have to be economic specific. Anything that relates to Cuba, that has an impact on Cuba, something that will be necessary for the economy, such as infrastructure, they're very open to having students present along those lines. And to be honest, ASCII, I think, is what sort of initiated all of this. They had a student competition. At the very beginning, our students would compete at ASCII. That was the only venue that was available. And then this evolved into this particular competition. So I just want to make sure that all the students are aware that there's a second competition. You can recompete these projects. The papers are due, I think, May 20th or 22nd. And then the actual conference is towards the end of July. So there's also prize money there as well. The competition will be a little bit more broad in terms of not only engineering, but other disciplines. So.
The slide before.
Okay. Oh, okay, you have this. Okay, I wasn't sure if you had this. Yeah, so this is more detail about the competition. More information and details are available at ascicuba.org. And again, the requirements are listed here. And again, May 20th is the deadline. You have the prizes listed there for graduate students versus undergraduate students. Okay, thank you.
Thank you, Dr. Solo. At this time, I would like to welcome Pete Martinez. He has been one of my great mentors and champions of a lot of the things that we do here with the organization. He has been a mentor to some of the teams here today, and he wanted to give some words of advice, because I think this is a very strong learning process.
Terrific. How do you leverage today? This is very, very important for all of you, because this is not about the money. Think of the opportunity that you had in front of some very, very world luminaries in your profession. These are your future bosses. These are the future leaders in you. You had the opportunity to stand in front of them and present a perspective about innovation, social impact, and monetary responsibility related to a project. You will not get another opportunity until you're probably 5 to 10 years into your profession to be able to do something like this. This is the advantage of this type of opportunity. So for you, the concept of what's important in business and the overall perspective was very key. The reason the questions were tough is to toughen you up. This was not about a participation trophy or patting you on the back. This is about real life experience that you're going to get through the grill that you're normally going to do. In business, there's no participation trophy. You either win or you lose. And when you lose, you learn and you come back and fight another day. So this is what business is all about, and you've had a rare opportunity. So how do you leverage this? The first thing you do is you put this in your resume. You're a finalist in an international competition, and do it proudly. Second, every one of the mentors that you have, you ask them for a letter of recommendation. Because as you start applying for internships or for positions in the corporate world, these are the people that will count. There's nothing more valuable than a letter of recommendation. The third is internships. It is very appropriate for you to talk to the judges, the mentors that you've had, and said, by the way, I'm interested in a position related to your business. Do you have it, or can you recommend somebody that has a position like what? And finally, for employment. You have impressed everybody here. There's no question about it. For the notion that some of you have already graduated, but they're freshmen here that were presented today, and they were talking about things that most industry perspectives would not even touch for the next 10 years in business. That we have freshmen in here participating is a wonderful thing. And they're talking about the technologies that us consider to be kind of frightening to us, like artificial intelligence, machine learning, and sensors and everything else. But you are the future of our profession. And this is why we consider it of ultimate importance to give you the opportunity to carry the banner forward for us. So leverage the opportunity, leverage the contacts that you've made, leverage the branding of this organization and the competition to your benefit. Congratulations to all, and take it forward and fight hard. Thank you.
Thank you, Pete. At this time, I do want to open it up for the judges to give some of their brief commentary on the 6 presentations today before we move on to the awards.
I'm going to be general. To follow up on what Pete said. In the future, you're going to be making presentations to businesses, putting forth a proposal, etc. There were items in the papers that I noticed that will not go well when you're making a presentation. You need to have clear statements of objectives. What is the problem that you're trying to solve? What are the proposed solutions, and what were the alternatives you considered and were rejected? Some of those were not clear in some of the written materials. There were grammar errors and typos in some of the papers. That might be a block to someone actually listening to your presentation or putting in forward a pitch for whatever project you're going to. So be careful with some of the written materials. There were paragraphs that were incomplete, something had dropped out, which you should have caught before submitting the materials. Conclusion sections, some of them were great, some of them were okay. And these comments are all intended to be constructive. Pay attention to it, because it does matter when you're actually making a presentation to someone. In this particular case, remember to consider the reality of Cuba. It's not like every other country out there. It's a communist country, totalitarian, with significant restrictions on what can and cannot be done, and very limited on an economic basis. So keep that in mind. I know some of you try to do that in your presentations and in your papers, particularly on the economic analysis. But while it may be that in the future Cuba is going to be a normal market economy, et cetera, we're talking 20, 30 years down the road probably before you get there. So keep in mind that there's significant restrictions in the meantime. So with that, I was impressed by all your presentations, and I commend you on making the effort, and the future is bright, given what I saw.
Great. Well, first let me praise you in engaging in this type of competition. It is extremely difficult to get into this type of project presentation when you don't have enough data. It's extremely difficult to gather data from Cuba. We had not a great level of communication, as you all know. So engaging in that, in reality, I mean, you have done a magnificent job. In general, I mean, in reality, I think I've been here through the years. It seems to me now that the presentations that I'm seeing are a little bit more sophisticated than the one that I saw at the beginning. So it's getting really, really good from all the students that are coming from different universities. And actually, we have more participation than in the past. In the past, it was more locally here in Florida. We have we have UF, and we have FIU. Now we have people from Illinois, from George Mason, all the universities that are coming here. In the future, and it was emphasized by Pete and by my colleague here, Mario, you're going to be facing a lot of competition. I mean, you're going to see that would be when you become graduate, become a professional, you're going to see that the majority of the work or the jobs that you're going to be is going to be on the competition, and you're going to be competing against, good group of engineers. They are fighting and fighting to get the job. So I think it's a good beginning. And congratulations to you all. Thank you.
So great job. Great job to all of you, because just the fact that you're presenting today is because you did a great job. Second, because you are practicing for the future. This, more than a competition, this will be your future. When you start working and then you need to present a project, you need to make sure that you have all the elements. And this activity today helped you on that. And all of you did a great job. Of course, you can always improve. So take all these great advices that you're getting today, like to improve into your future, especially when you start working in your future career. Not as a student. Don't think of this as a homework, a project that I did for my class. This is something that's what you might be doing in the future as an engineer. So take this advice for that benefit, and in general, my own personal advice, when you do something, take it seriously. That will help you a lot. Take it seriously. And if you're, in this case, it was about Cuba, try to understand more about what you want to implement, and try to understand what's happening in there, and try to understand how your proposals are going to be able to actually implement it or not. And maybe just using the internet because you don't have enough resources, sometimes it's not enough. How do you go above that? How do you go outside of the box? So, and if you do have the expertise about the area that you're talking, try to make sure that yes, you're going to do the best out of you to try to see if it happens. Not just as a, yeah, hopefully someday it's going to happen. No, I'm doing this because it's serious. I want this to happen. So not just about today. Think about this in the future. When you're already working and you're presenting, demonstrate that you believe in your product and you went above and beyond to make it happen. But in general, great job. I was really happy to be here today and listening to all your projects, and congratulations to all of you.
Well, first and foremost, congratulations to all of you. You're all winners. Tackling a real problem is not easy. The first thing is, as engineers, as compared to technicians, if you have a problem, they go to the book and they find the solution. Engineers, we work with problems that we don't know. We will face a lot of questions along the way. So this is actually, I echo everything that was said by my colleagues before, but this is real life experience. Whatever you do in life, you're going to find as a professional that you're going to have more questions than answers. Because if you have the answers, you don't need to do it. You have a technician doing it. Okay? So you'll be resolving things in real life. Also, I want to echo what Pete said. This is probably the first, for most of you, of real life experience. You're actually here competing for something real. In the future, you'll be there with a world that is not as nice. I tell you some of my experiences in engineering. We were developing a modem. I worked for a company who actually invented the modem, and we were behind because of a Chicago company I'm not going to mention, got something better. I said, oh, we're going to do it 10 times faster. And we got to a trade show, and there was 3 competitors doing it 1,000 times faster. So here you are investing millions of real dollars, not Mickey Mouse dollars, real dollars, with a lot of jobs, and the company went bankrupt. $1.1 billion in sales, went bankrupt within a year. So these things are real. This is not Mickey Mouse. Another thing that I wanted to emphasize, that was exposed by one of the presenters, but I think is a lesson for all of us. We need to look at the social, not only the economic aspects, but the social aspects, the consequences of whatever we do. I think we all engineers, we're very lucky. Our profession literally is manifested in everything that surrounds us. The buildings that we live, the transportation that we use, the way we communicate, there's nothing that has not been touched by an engineer. You are the new generation that are going to be carrying out whatever you do is going to impact not only your generation, but hopefully hundreds of years ahead of you. So take it seriously. Have fun. That's very important. But realize that it's not only the solution, how that solution impacts others. Okay? You can't design, look at the 737 MAX. You can't design something that people are going to be dead. You see, we can kill people by making a mistake. So take these things fun, but seriously at the same time. So there's a lot of factors going there. Anyway, congratulations to all of you. You're all winners.
Thank you so much, judges. At this time, I do want to thank you all, and we want to present you with some certificates of appreciation. So when we call you up, if you can come up to do that. So we'll start with Mario Villar, the other Mario. We'll start over there. Double bond.
I thought it was for
Thank you. Eduardo?
Okay.
Eduardo has been a long-time judge.
Yes, yeah, I'm about to retire. I'm going to get benefits too.
Thank you. For our first-time judge, Antonio Delgado, bringing all of the expertise specifically from Cuba,
Yeah.
so thank you so much.
He's signing, you know.
Thank you. And last but not least, Mr. Mario Sergio Golab, Doctor Mario Sergio Golab. Ingeniero. Thank you. We truly couldn't accomplish what we did today without these judges. They did spend a lot of time reading the materials, looking at ways to provide more feedback, which you'll get after today. And they have been here supporting our program for a really long time now. So again, one big round of applause for our 4 judges today. All right, so this is the time you guys have been waiting for. So we met over lunch and we looked at the written proposal scores and also the oral scores as well for these presentations. And we have quantified the total ranking from 100 points. So 40 available from the written, 60 available from the oral. And at this point, some of the scores were very close, and we had some close calls, some tiebreakers that had to be broken, but I think we're all really excited with what was accomplished here today. So I would like to start the award ceremony by recognizing those participants outside of the top 3. So we have a first, second, and third place, and then there's obviously 3 other teams that did not achieve those scores, but I think that they all scored pretty high in terms of these higher scores. So we'll start there, and then we'll work on backwards, okay? So when I call your name, if you can come up with your team and accept the certificates. So the first participating certificates will go to the team for BYU. So Chris, Riley, Jacob, sorry. This is on you, Chris. All right, so in the middle. Perfect. Thank you. I did forget to mention that all of the team participating here do get a 1-year membership to our organization. So I think that's where that winning and being able to continue this work, and whether it's next year or the year after, is definitely really exciting. The second team that will be receiving a participation award is the team from Georgia Tech. This is on your name. Okay. So moving on, the third team receiving a participation certificate is the FIU team. Lázaro, Maria, and Eric. Okay, thank you. All right, so moving on, we will be awarding the third place award, and that will be going to George Mason University and Mr. Sherwin. Congratulations. There's a check. Thank you. All right, so I think this kind of tells you the moment we've been waiting for. A little bit of drum rolls, one. A little bit. All right, so second place will be going to Illinois Institute. Okay. Congratulations. Jorge, here, that's yours. Matt and Ivan. Long way from Spain, from Chicago. All right, but by order of, I guess, non-pronouncing, the first place goes to the University of Florida, Mr. Luis Gonzalez. Congratulations. This, all this in the back.
There you go. It's a Cuban pesos, huh? There you go.
Thank you. Again, congratulations to all of the teams that participated here. Some of you have come from really, really far, and I think the organization is very proud of that and being able to have you here today. I do want to open it up to Jose Enrique, who's the president-elect for the Association of Civil Engineers, and to speak on behalf of the civil engineers here before we close off.
Sure. And I'll be brief because I know we've been here for some time. I just wanted to, on behalf of the Cuban-American Association of Civil Engineers, our president and our board, thank everyone, the students, of course, your families that have, of course, supported you to be here, and our judges. It really inspires us every year that we do this, that so many folks, local and, of course, of Cuban descent or relatives or friends, but not only that, also folks who have no connection to Cuba whatsoever, have so much interest in our country and our heritage and also our issues here and in Cuba. So thank you very much for that, for your interest and for participating. Being a member of the Cuban-American Association of Civil Engineers, it was also very encouraging to see so many projects, I think all, if not most, if not all the projects being civil focused, and particularly on water, which happens to be my area of interest and my expertise. So we're very encouraged to see that, and we invite each of you, as Regina said, to become members of our organization, to stay active, whether you're here in Miami or live elsewhere. There's many ways to participate and continue to be involved with our group here in Miami, and hopefully, as we all here, hope in a future democratic Cuba. So thank you all very much, and we look forward to seeing you next year. Please spread the word to your colleagues. We hope to see each university that's participated here today in the 2020 competition as well. So thank you all very much. And of course, I'd be remiss if we did not thank Regina Rodriguez for all of her help. She has been central to putting this entire event together on behalf of both organizations. So Regina, thank you so much. A success as always. Hats off. Thank you, Regina.
Thank you.
No, I appreciate that. I think from being here in this competition 5-6 years ago and being able to grow with the organization has been something that I'm really excited for, and I think as we continue, for you guys to continue to be involved and participate, to continue to grow the young professionals in not just Cubans, but interested in Cuba, like Jose Enriquez said. So without further ado, I know most of you had long travels to get here. So with that, we're going to close the ceremony, and I look forward to seeing you guys all here in 2020. So thank you so much for today.